Assalamu alaikum, everyone. I hope you all can hear and see me and Mesum. So, welcome. Okay, yeah, everyone can hear me. Great. So, welcome to the 10th meetup of Karachi AI. This meetup is a bit special because it's online and virtual, and we can already see from the chat that people from all around the world can listen to us and see us and participate in this meetup. That's great. Welcome, everyone. So this is Kamar from IBM. I am a developer advocate lead for Pakistan. I have here with me my teammates, Muhammad Ali and Huzaifa Salim. Guys, say hi in the chat. And I have with me Mesum, who is the lead for the Karachi AI data science community. So over to you, Mesum.
Thank you, Kamar. Hello, everyone. Thank you for joining. Just officially starting up the meetup. So let's start with the glimpse of what Karachi AI is. So you get it. So before starting the session, just confirming with my host, hopefully we are live and people can see us on Facebook and YouTube simultaneously. Kamar, can you confirm me up if we are completely live?
Yeah, we are completely live. Let me ask Ali if he's checking on the other. Ali?
Okay, so my Facebook is
Yeah,
saying
yeah, he
that
has
we
just
are
saying that
live
we are live on YouTube and Facebook
and
as well.
YouTube as well. Okay, thank you.
Okay,
So
perfect.
you can follow us on LinkedIn as well. And those people who want to earn this one-time special certificate co-authored by IBM and Karachi AI, you just sign up the link rebrandly.karachi AI underscore meetup underscore register, and your name should be there, right? 80% of your time should be dedicated to this event in order to earn the certificate. Thank you. So just starting with the introduction to Karachi.ai, what we do. We are an applied artificial intelligence community. So what we do is we do meetups, education, and alliances. So here, when we started into Karachi.ai, there was a time where data science communities were disconnected from the industry. So we led this initiative into where we place networking events. We bring in companies that are working in data science and machine learning, and alliances we make with different companies so that people who have learned this skill out, they can be placed into the industry and they can serve the nation. So covering up the meetups part, generally our meetups, the nine out of 10th event have been conducted on premises. So generally they are 15-minute talks, 15 to 20-minute talks, followed by each speaker. And there is an AI clinic for instant feedback. Generally, it ends up into a networking session where people can have a good networking and community meetup at on a great lunch or dinner, or however the time it is. And we do appreciate our speakers, distribute the certificate of appreciation participation. This is the generally we do on premises and a physical certificates. This is the first time we will be issuing lifetime digital badges to you guys. And we have community groups. There is a group on Facebook called Karachi.ai. You can join it out. So the next part is education, and this is where the whole area was missing out. The missing link. So we started the mentorship circle. So there are a lot of people available from the NLP, AI, machine learning background that have been skilled and have crossed the stage of being of the expertise, right? So those who are starting into the career or into the mid level of the machine learning concepts, they can approach them up and as a mentor, and they can connect up with. The next comes up with online self-paced courses. So Karachi AI has provided a guideline on the Facebook group. You can find in units. So that is a complete Coursera curriculum that you can do a couple of specializations in order to learn the data science and machine learning in entirety, right? Then followed by the hands-on workshops. Generally, people have an obsession that we need to learn from the instructor directly. So many people, on a lot of requests, we have started some hands-on workshops. We do also deliver courses. The next slide follows up with this vision as well. So this is one of our course offering that is called Certified Data Analyst. It's in collaboration with Fast University, and we teach Python programming, information statistics, data visualization, and machine learning. So this course is a 3.5 months package that enables any people from any domain, whether you are not a CS graduate or a CS graduate, enable you to plug and play into the industry as a data scientist, as a data analyst. So there are some brief details that you can follow up on the course as well, and you can see out certified data analyst on the Facebook. We are currently offering it on premises, so many people from Karachi are connected. If they want to enroll into the course, they are most welcome. These are some of our partners that people, when graduate, they get placed into Telemarks, Baikia, Marketritics, FedSky, and many other companies that we have. So if you want to get enrolled, you can scan this QR or search this Facebook page. And cutting up the short, the last part is the alliances that we do. So we are very well connected with Pasha, Tech Pakistan, Momentum, and many other Pakistan Software Expo Board, many other trade organizations and IT organizations that are promoting the use of technology. So they have helped us to enable many large scale AI events here in Karachi and as well as globally, right? So talking about our impact, to be honest, we have conducted a various meetups, of which our impact, some of the impact have been summarized. Till now, it's a very journey towards the 10 quarterly meetups. It's been around 3.5 years till now. We are a large community of 5,000 individuals. We have conducted these events into 7 universities of Karachi, and 3 grand AI events partnered with us, right? So I can quote this event as one of the grandest of them all. So this count becomes a 4. 30 industry academia partnerships. We have 5 regional chapters: Karachi.ai, Lahore.ai, Peshawar.ai, Islamabad.ai, and Quetta.ai. We have graduated 3 batches of certified data analysts, and more course offerings are being rolled out. If you catch up our YouTube channel, that is provided into the link, so you can see our 50 plus hours content that has been tailored specifically for the subcontinental people. That content is available in Urdu and Hindi. So if you go through all the content, I bet you will get a great aspect of the what data science and machine learning is, and our 9 meetups have been recorded there. So finally, we are ranked #1 on the City AI network because we are reporting up to the City.ai network. Finally, if you see on the global landscape, we are there with Lahore, Karachi, and Islamabad.ai. So ignoring my introduction from myself, I am being the founder and ambassador. We have good people as a director on board, Ali Raza and Noman Khalid. Ali Raza is the CTO of BitSwitch, and Noman Khalid is the partner of Love for Data. We have wonderful Heather Ali with us and Tala Khan, who are working in the back with us today in the today's event. And if you want to volunteer with us, you can join us. So before the event starts, these are some of the credentials if you want to join the community, and if haven't yet, or if you want to bring in more friends, you can just log on to this link for the event for https rebrand.ly karachi.ai meetup_online, right? So just a couple of seconds if you want to copy up this link or note it down. Perfect. So I want to, first of all, I want to congratulate each and everyone who has made this landmark event possible, especially IBM, people from IBM, Kamrun Nisa, Muhammad Ali, and their backend team who have enabled us to deliver such a large scale without any hassle. So again, once again, thankful to our IBM, AWS, Temple's University for partnering with us. Alhamdulillah, we have been able to capture 400 plus participants officially, right? And if you haven't registered, you are seeing the live stream and you want a certificate, just get on to the Rebrandly link. So today with us, we have a very good lineup on board. There are some of the 2 speakers missing up into. I can put later their images up to. So we will be having Moiz Ali from PyCaret. We will be having Dr. from IBM Watson Cloud, Mr. People from IBM Watson Cloud, people Scott from KNIME Analytics, and me myself would be presenting the Streamlit Fast API. and Google Cloud ML, Mustafa Ali, and Aksa Kausar will be joining. And from AWS, there will be Talal Shaukat. So introducing myself, I'm just skipping up what my introduction is. You can later see on my LinkedIn profile. You can find me on Mesum Raza Hemani on LinkedIn. So today we will be covering out of how Streamlit works and what Fast API is and how ML-based services works. Okay, so rapid prototyping with Streamlit. Streamlit is an open source platform that enables you to to provide machine learning and data science teams, right? And create beautiful apps on the Python stack and in a very easier way, right? You don't need to write a long code for the GUI into the complexity itself. Streamlit provides you on the runtime very soft uh, enable containers that enables you for the delivering of the data science pipelines. Okay. So Streamlit has three ideas, right? It's completely Python scripting, so it's very fast, and it's an API based, so that can be called very easily. You can do interactions. So there are a lot of interaction widgets from date pickers, from the range selectors, from the buttons and everything. You can explore the Streamlit libraries and components out and deploy instantly. So right in the different servers, you need to write a complex code and deployment knowledge you need to have. It's a very easy framework that enables you to deploy the Streamlit applications on your local host and as well as on the cloud, such as Heroku platform, on Azure, or any other platform that you want to host with. Okay, so if we start with just looking out, the simple script to run your Streamlit app is, and if you download my application, if you want to run is, so first of all, you need to install pip install Streamlit into your packages, and then followed by, you can write Streamlit run and my script or your script, whatever it is, and you can pass arguments as well. So this opens a localhost container and runs all the application on the web browser. So so the best thing about the Streamlit is, generally you need to first write the code and again load into and develop and deploy, right? What the best thing is about the Streamlit is, you change the code and Streamlit automatically analyzes the code and finds the changes and deploys it automatically, right? So the time to deliver the application reduces up, and you are able to perform the creation of UI a very faster way, right? I'll be demonstrating you out so that you will be very much amazed how easy and responsive is the Streamlit is, and how easier life from today you're going to be. Okay, so when it comes to the data flow, you can write application architecture on the Streamlit in a form of Python script. So it's not a Jupyter notebook based framework. It will be a .py file that you need to write and run then later. So if you want to write and draw the content, just let me show you the one of the applications that I have created for this session. Kamer, can you please guide me up how I can share another screen?
Yeah, have you stopped sharing that screen? Yeah, just share your screen again.
Okay.
Yeah, that's simple.
It's my time for a while. I'm sharing my entire screen. This goes.
Yep, you can see that.
Okay.
Okay, perfect.
Okay, just let it load. It's on Heroku platform, so the app might be sleeping because the worker node might be sleeping right now. Just for a while, if it loads.
Mesum, in the meantime, maybe you can ask some questions. So people are saying, how can they volunteer for your meetups, the Karachi
Okay.
AI meetups?
Okay. So those who want to volunteer with us, they can reach out to Karachi@city.ai and write a small application that they want to volunteer with us. We will share a form where they can fill out their details.
Okay, thank you.
Okay, so this is one of the diabetes prediction app that we are going to today conduct with, and if you can see, I was saying that there are very interactive available things that you can do with in Streamlit. So this is one of the headers, and there are fields different. So the whole app is all about the diabetes prediction. So you get for just imagine you think about there are patient comes in, you take some values of around pregnancy, their glucose, their blood pressure, their skin thickness, and different factors out, and then you can click here to predict with your machine learning model is the person diabetic or not, right? So this is the whole theme of the today's talk, and this is the use case we are going to work with. The platform of Streamlit that we are going to demonstrate you today. So what if I want to create this input value skin thickness input parameter? So what I need to do? Okay, so coming back to the talk, you can draw the content very easily. So you do what you do is write a basic script, import Streamlit as st, or you can give any anchor out. For example, you write st.write. So as you write st.write, your screen delivers a text method for you to implement with, right? Just let me give you a glimpse of what I'm talking about. Okay, this is the GitHub project. You can mark it as a star if you want to see the application. Okay, so coming back to the topic, here if you can see the script, I have imported the Streamlit ST, right? And then what to deliver the parameter input value, I have given.
Mesum, can you please zoom in a bit?
Okay, can everyone see?
Yeah, it's much more better.
Okay, so I have called
Yeah.
st.number.input, right? Rest is the programming that I need to do. I use a programmatic way to call many containers of the number input value, but the itself is very easy. That you can see st.title your input summary, and what you can see is your input summary. So what this app does, if you see, it works in a very procedural way. If you see here is the st dot button. In the first way, we are going to list what the title is, st dot title input summary. There is a right parameter dictionary. You can see the button. So my diabetes app prediction app, there are fields that I have recursively presented here is Streamlit components that are input values. You see the input summary, and you have a JSON summary as well. And then there is a button that you click, and there comes a prediction from it, right? So hopefully, if you have the concept of how Streamlit enables you to draw the widgets, so you just need to write st dot write st dot input or many other. You can explore the Streamlit library. If you want to draw a slider, you just need to do st dot slider and you put on the text that you need to represent above the slider. Hopefully that is clear. Kamar, my screen is visible.
Yes.
So just covering up from the start, if we see what are the requirements for today's session we going to do. So we are using Python 3.6 or later. We need to have Python installation package that is called pip, and there is a Streamlit library that I call pip install Streamlit, right? So how you start work with is import Streamlit as st. You just write a Python script, first app.py, and you can try it out live on your server as well if you installed it out. Import Streamlit as st, and you wrote the you write the specific code as st.write. My name is, and insert your name into the quoted, and then you can just save the .py file and do Streamlit run first app.py. Let me just demonstrate how we're going to work with. Okay, so this is one of the app. What I am going to do is import Streamlit as st, and Let's ignore notepad. st.write my first app, right, in Streamlit. What I'm going to do is st.title. So you get a very large heading. I'm going to save this application on my desktop as my underscore first underscore app dot py. Save.
Mason, can you please zoom in a bit because people are saying they can see it a bit
Okay.
blurry.
Can you see the
Yeah.
code?
Okay. Okay. Yeah. Perfect.
It's very, very easy, right?
Yeah.
That- Okay. So I'm just opening up the command prompt from here using the PowerShell for now.
Mm-hmm.
This is what I called
Okay.
Streamlit run my first app.py. Now it's going to open up the localhost, right? No Django browser configuration needed, nothing needed. Simple. You got your first app in Streamlit. Congratulations. So hopefully everyone has been able to install the Streamlit library and follow up via. So we are going to go very quick. So this would not be a following tutorial that you can follow up along with me, but you can later look into the GitHub and for the details, right? So we are doing a Pema Indians diabetes database. That is a very, very vanilla use case that many people have implemented in machine learning model for learning different things, right? So there are some of the factors that is pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes predictive function, and age. So these are the some of the predictors that we would be inputting up, and our app would be predicting up the probability of if a person is diabetic or not, and what probability it concerns, right? So if you break down the requirement, this is the requirement from one of our boss or one of our customer. We can see there should be a heading for my diabetes app prediction app. There should be sequence parameters that should have default values and descriptions, right? So if we see the application itself, let me just switch up to the responsive. So our requirement is to have some heading. Each input should have a heading and a descriptor that what needs to be inputted. It should be a number value, and then you should have a summary, and then you should have a button to predict with, right? So this is the whole requirement that we are today concluding it with. So that is a display of input, button to execute the prediction, and prediction outcome of with the confidence. Kamala, everyone is able to see the screen and is
Yeah.
visible. Okay.
Yeah, everything is right. They're just saying that they cannot see the video, see the slides completely because our videos are showing up. So I'm just turning off your video so that and mine as well, so that
Yep.
people can see the screen
Sure,
clearly.
sure.
Okay.
Please turn off my video. That would be great.
Okay. Yeah, I did. Please go on.
Okay. So the next thing we are coming up with, we are going to implement these things. So in order to create the UI interactive objects, we are just doing some Pythonic way of work in order to do quick implementation of the screen widgets, right? So first of all, I have created a parameter list that is pregnancies, glucose, and everything that is required to be input. I have created a blank list that is to be parameter input values. I have given a parameter description that is again a Python list. So that is not nearly necessary, but I am just explaining out. So when you see the my GitHub code, you don't get confused with. These are some of the default values that load up with. So if you see, what I have done is, if I refresh this application, you see input value for pregnancies. This is the field names that is coming from here. If you see what the glucose is, number of times pregnant. So number of times pregnant is coming from here, from this list, and the default value is set to 6. That is coming from 6, right? So hopefully these three things are clear to you. Now we will be creating UI objects. So that is very, very easy. We are using Streamlit number input because that is relevant to our use case. What you need to give it out, there should be a label, there should be a key and a value. So if you are using multiple similar types of input types, that is a number inputs, so you need to provide a unique key so that Streamlit recognizes each and every field with a different key, right? Else it will throw an error out. Okay, so there is a label, some guide text. We will fit parameter description here, what we did. Okay, so there is a key. So that key is pregnancies. There is a value. So what we will fit out the number 6, and we will currently ignore. There are a lot of other inputs as well in the number input API, but we will ignore them out. Okay. So next is coming up to creating UI interface and interactive objects. Okay, so what I've done is I'm a bit lazy programmer, so I have tried to programmatically run a loop on my requirement. So I get 6 parameter fields. You can just explore the loop out so you can understand what I have done. It is the same thing what I have done, but rather you can just explore it out how I have implemented in loop. So what the first thing does is my diabetes prediction app. What I have done is here you can see the title. You can see I have run a loop for this for parameter in df, and I have zipped it out and implemented into. So I get what I get is programmatically get these 6 fields. You can see I have put encapsulated all these parameters what the user inputs into a parameter dictionary. I have given a your input summary and parameter dictionary. So your input summary and parameter dictionary. So st.write, if you see, you can use as a global writer for anything out, right? If you provided it a pandas data frame, it will output a data frame on the screen. If you provide it with a text, it will provide the text on the screen. If you provide it with a JSON, it will provide you this like dictionary type. So dictionary is kind of a JSON. So that is being inputted as what have user has been input. So if I change 50 to 50, for example, if I write 52, so it also changes into 52, right? So Streamlit is updating all the things in live. You don't need any callback mechanism for your input. In the last applications, in the other applications other than Streamlit, you need callback methods in order to get a response for your widget state. So no need to control the widget state and everything. Streamlit is very easy for that. So now we have at the end of the we have a button. So in the button logic, what we can do. So before we can have a prediction logic into our button, we need to have something that needs to be executed. So for this Streamlit part, I'm just demonstrating you out. Today we are also going to be discussing the fast API. So hopefully you don't get confused whether you have to implement Streamlit with fast API or Streamlit itself alone can work. So right now I am demonstrating how Streamlit alone can work, and then I'll be demonstrating you out that how you can call the API on the button as well. So you get the both flavors. If you want to deploy Streamlit alone itself without an API, it will completely work as a standalone application. And if you want to interact with an API, for example, you have a Google Cloud Services API or a for example, if you have Google Maps API, so you can interact with button as well on that. So what I am doing today is I have processed a machine learning model and exported that into a pickle file. So that is diabetes model. I'll be using job lib load for this purpose. I have defined a prediction function that outputs us the prediction value. So you can ignore this fetchy code, and you can see out in the GitHub how it works. So on the button platform, what I'm trying to do is if st.button, click here to predict, right? So this is click here to predict is being st.button. And then what I have done is I have used the prediction value, whatever has been passed into that parameter, it works into, sorry. Okay, so it works into. All the things are done. And as I click here to predict, what it does, it processes the things and it gives an output of confidence, right? Kamar, are we following with, and hopefully the things are clear with?
Yes, they're actually asking about that it's blurry or if the recording will be available. There are a few questions, but I think we should do them at the end.
Okay, okay,
Is
sounds good.
to maintain our time schedule.
Sounds good. So what at the end of the day, sc dot write your diabetes prediction is what I have encapsulated as parameters are available here. So hopefully we have created a first application for our diabetes model. You can see my application on. You can find this application as complete code as my first app streamlit.py that is being completely provided. I can share the link of this script in the chat session as well. Okay. So this, if you are very confused around how Streamlit works, how I'm going to remember so many commands for Streamlit, so this is a very good cheat sheet. I'll be sharing you this slide that you can refer and keep up with. So that enables you to not remember the code itself, but rather recall the logics of the code, right? So this is a cheat sheet for you guys. Okay. So if we summarize what we did in order to deliver this small app application that we saw into. So we created UI objects that was a very few lines of code, and then we imported a model. We use Pickle, or we can use an API for calling. Right now we use a Pickle model, and we will in the next in the upcoming thing we will be discussing Fast API. So how we can consume Fast API into Streamlit model. Then what we did is we pass the parameters from the Streamlit to the model outputs, and again we come up to the Streamlit. So hopefully the overall flow is clear to you. If you are going to deploy on the Heroku itself, so what you will need is a proc file. So you need to have the script on your GitHub, your requirements txt that is to be into a file that I need Streamlit version 0.55, pandas 24, and scikit-learn 22. So in order to process the file, right? And when deploying on the Heroku, you need to have the same configuration from Streamlit, run, enable cores, and false. That all things are available here in my code. If you can see here, just let me demonstrate. You can see the proc file here. So everything is available here in proc file. You can later, after the session, you can see how you can deploy on Heroku. There is a diabetes model, so you can also completely download the code in entirety and run this code on your local host as well, right? So here is the requirements txt that have been implemented into. Okay, so now coming up to the Fast API. So in the last session, we understood how Streamlit can standalone work itself and completely deliver a machine learning application or data science implementation that you need to show up into your organization in a single day, right? So that this enables you to deliver the GUI very faster and show your concepts around the machine learning very easily. So there is a called Fast API, and why is it called Fast API? I'll be just letting you know why it is, but you can remember from its name, it's very high performance, it's very fast and easy and ready to go for production. So when if I can explain my background, I am a chartered accountant myself. So I find generally the coding things very hard and difficult. I'm not a CS graduate, right? So I found out Streamlit. If I want to easily implement the GUI, so I can implement with Streamlit. And if I easily want to implement APIs, now I have the platform of Fast APIs. So it is becoming more of a domain expertise rather than knowing of the code. So people going to do it, but you are learning into it. Okay, so some of the testimonials, where is Fast API being used? So it's being used by Uber, it's being used by Microsoft in an implementation. Netflix is also using the Fast API for the implementation. So what's very special about the Fast API? So what is let's get started with how Fast API needs to be getting work. So you first type in pip install Fast API, so you get the Fast API, and then you need a server as well. So pip install Uvicon. Fast API is native to Uvicon, and you can run very fast on your API as well. So let's see it out how we gonna code up the very small application. If you can type into from Fast API, import Fast API, app Fast API, and then app-get. So just let me demonstrate what I am telling about. You just import Fast API, and there is a package. You put this Fast API into an application package, and then this app gives you a decorator. And this decorator is very powerful. When you work with uh, Flask API, you need to handle the data types itself, all the application bind parameters itself. Now, what Fast API does, it does all the things for you. Just implement the method and it understands, right? So there is a application app.get. slash. So this, when person hits the your API in a native way, he gets a message hello Donald, right? So it returns a method that called message hello Donald. It gives a message called hello Donald. This is a JSON that is being passed around. You can see the JSON. If you want to run this app, you can save this code and go into your CMD. You can use it around Ubicon main map. So your main application would start running if you save the application with main.py. Or just if you want to completely run this app on your own, so what you can do is you can put a main method into it, and you put on Ubicon run, and this copy up this code out, right? So if we start comparing Flask with Fast API, you can see in Flask, what you need to do is you need to completely route and then handle the data types itself. Your methods need to be hard coded, that what kind of data types you would expect, what kind of data are you going to infer. But when it comes to Fast API enables you to implement the methods very, very easily. So if I have a method called def predict. So what I did is app.get slash API diabetes, what I have given a root for that, and this method is automatically inferred into API. So when you see the documents of the API, you can see that a string payload is required for this API. It automatically generates the documentation of the API itself, so that if you are going to provide API someone for commercial use, they get the documentation itself, how to use the APIs, what are the required parameters, what are the optional parameters, right? Kamal, is my screen visible and voice?
Yes, yes. Yep. Please carry on.
Okay. So
Okay,
I
this
am
is a bit blurry. Can you please zoom into that?
okay. Okay. Let me just check if can zoom. Okay,
Yeah.
it's zooming more than what's required. Okay, so
Okay.
just telling out the summary. There is a benchmark, internet benchmark. You can see fast API comparison, and you can see how fast API is on the number one, right? So it's showing the benchmark at the 100% in a fast API, and all the other platforms that provide the API or enable API are slow in comparison to fast API. So what we are learning is a very, very world class best library for making APIs. I am not ignoring the flexibility of Flask API, but rather you can develop very, very quick into fast API. Okay, so what's bonus about the Flask API? Well, if everything can be done in Flask, why go for Fast API, right? So Fast API gives you a completely enabled documentation for free, and you get the API documentation without any code to write with. If we see, let me just demonstrate you what kind of demonstration you get it. I write slash docs. So if you want to see what my API does is, okay, just let me copy it up. It's opening up. Okay. So here you see the complete Swagger UI. You get the complete documentation of what your API does, how it works, and I had to write a zero code for this complete documentation, right? So generally, when you deliver your clients APIs on Upwork on your production environments, there you need the documentation to communicate with other team what your API does, right? So this is what Flask API does, and you can also get a very awesome flavor of another documentation there where you can test your things out as well. That is called a redoc. So here you can input as well your values, and you can completely get your API working as well. So this is the Swagger UI. You can put your responses, you can put validation and payloads into it and test your API. Like if you click try it out, you can put the complete payload and it executes. Let me just demonstrate you out how it works. Okay. So what I'm doing is to copy up the default values. me into it. Hopefully the API is visible.
Yeah, can you please zoom in a bit?
Yeah. So API gives a response of the 200 code. Just let me just stick it out, but you can see the response of the API as well, right? So what I am doing is, if you see this application, when you click this button, it hits the fast API in background, right? It generates this link. So if you can see this link, it's giving a payload completely of this. So this is what fast API does. So you get a bonus documentation and a free kind of implementer as well. You can check the complete code of fast API I have written into. Just let me demonstrate you out.
Okay, Mesum,
Okay,
you have
so
2 minutes
we
left.
have fast API. Let me just zoom in out.
Yeah,
Is my
perfect.
screen visible?
Yep.
Okay, okay. So you can just ignore the first thing that GitHub imposes itself. From fast API, I have fast API. What I have done is what I did with the joblib library in the Streamlit standalone application. Now I am going to implement this model into the fast API. So the data comes in, the fast API processes with the scikit joblib library, and then renders the response back. So this API can be used into several applications as well, right? You can
Mm.
ignore the rate limits. That is a bonus topic that I'll be telling you out at the end of the session. I guess I have 5 minutes left into my session, so just let me go quick through into the cover. Again, the same is app fast API. I have loaded the model. What I have created is a def root. So if you see, okay. So let me just demonstrate you in a second. App.get, there is a diabetes prediction app, right? You can ignore the 60 seconds code. I'll tell you again. App.get/diabetes, you have implemented a method of predict. There will be a string payload that would be coming in. So my button would be throwing into the code of the string payload, right? What comes in is would be splitted by the values itself. Headers are provided into, and again the same implementation of the code is given that I wrote into the Streamlit application. But rather the Streamlit application uses, now it uses fast API. And let me just show you the code as well. Okay, so if I directly hit my API, that gives me this is a diabetes prediction fast API, right? And if I provided it completed, so you can see it out. Now let's move into where we can see our code. So I am saying fast API. Okay, so this is the code I have changed into. So there was a standalone application, and then this is a backend based application that is fast API based. Okay. So what I've done in this application is called the Streamlit. I have provided the URL API. I have created a call predictor function that calls the predictor APIs, that is URL lib.pass. I have encoded what the data comes into from the input fields, right? And then returns a response. When it comes to st.button, what it does is it calls the parameters, all the combines all the parameters put into the call prediction API. What call prediction API does is pass all the prediction API, encode into the URL and send to the fast API. And then what comes as a response is written as your diabetes prediction is prediction probability, and then you can show the docs here. So this is why when I click this application, it gives me a complete URL that was sent to the Fast API. It gives what Fast API is returning as a value, and you can see the complete API docs here as well that are live, and you can see how API is working into. So hopefully you have got a glimpse of what Fast API does, how easy it is to call. Now, what bonus is, when it comes to APIs, there are very sharp people who are going to use your API in a very disrespectful manner and use it to the rate limits, right? So generally in the APIs, people put into the rate limits that you can hit the API for 5,000 or 500 a day or 5 in an hour, so that your server doesn't get down. So what I have done is there is a package called from rate limit called import limits. I have imported the rate limit sort of. I have created a 60 seconds integer that has been, and this API implements what called at the rate limits and 5. So what I what it does is a period of, it takes the period and the number of calls. So in 60 seconds, I can just give 5 API calls, right? And the API will become irresponsive for the next 60 seconds, and again it will come back. So this is how I am saving my API from being bombarded or from being overused by applications, right? Let me just demonstrate you out. If I press this predict button multiple times, right? I press this button again, 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 and now what it does is becomes unresponsive. So now after 5 attempts, what it done is API response 500, right? After 60 seconds, again I'll put the button and the Fast API would start working again itself. However, is my screen visible and the concepts easier?
Uh, yes, but I would say that maybe you should wind up your presentation because there are a lot of questions.
Okay, okay. Let me just come to the conclusion itself.
Sure.
Okay, so in order to implement Fast API on Heroku, you need a Ubicon server that is being into the configuration. You can see how you can put the dependencies into the requirement txt. You can use the PPAC model that I provided as the diabetes model. So Heroku deployment is very easy that you can see. So it was very easy, just covering up in the fast way. What we did is we wrote first API hitting, that is diabetes prediction Fast API. What we did next is a URL request we created on the Streamlit application that enabled our button to call the predict API. What call predict API was doing is encode the parameters into the API and hit that up and get the response of that. Hopeful that you have got. I'm sure that my section was has enabled you to understand the concepts of Streamlit and Fast API in a very brief. There are a lot of concepts and questions in your mind as well. I'll try to answer some of them. What Kamal picks up, and
Mhm.
you can reach me out at the LinkedIn profile, or you can just comment out on the GitHub as well. You can note this Streamlit link app and what I provided as my GitHub, so you can look into the code as well. Kamar, can you please share any questions that we have on this platform?
Sure. There are actually like 14 questions, so I think maybe you can answer some on the comment and some I'm bringing up live. So
Okay.
someone is saying, if I use Streamlit for my visualization mapping, can it have a Dockerized image?
Yes, Streamlit can be dockerized as an image as well.
Okay. And what are the potential applications of Streamlit?
Okay, so just let me give you a quick glimpse of what Streamlit is doing. Streamlit.io. You can
Can
see
you please
thousands of
again?
applications. Some of them are here. People are creating computer vision based applications. You can see there's a face scan explorer, real time object detection. So it's complete real out. You can see out how streamlit.io/gallery. I can put that into chat. Okay.
Perfect.
Next question.
Okay, so there's a question, is Streamlit scalable? Can it handle shallow and deep learning models alike? And there's another one. And furthermore, is it scalable for big data?
Okay, so personally, I've tried Streamlit out. It works on a scalable fashion, but if you write a very Pythonic code, right? If you write a stressful code that is stressful on memory, stressful on web browser itself, then Streamlit would be a bit handling. But hopefully, Streamlit is developing the models again and again, and new releases are coming into, and that is becoming more efficient and efficient.
All right, thank you. So,
Sounds good. Sounds good. Thank you, everyone. I think
all
my
right,
session is concluded, and
yes,
hopefully
thank you, Mesum.
everyone enjoyed.
Yes, thank you, Mesum, for joining. So, furthermore, I would like to introduce Dr. Margaret for her next talk. Hi, Margaret.
Hi, hello.
All right.
You,
Yes, I
you
can
are
hear you.
hearing me. Oh, perfect.
All right, perfect. Please go on. The floor is yours.
Great, thank you. I'm going to talk a little bit about the work I've been doing. Let me try to find how to share my screen. And are you seeing the slides?
Yes.
Great. So yes, I'm going to talk about what we're working on with IBM Watson in cloud. So how to build models, deploy them, and then also use them through an API, and also we'll look at monitor them in OpenScale. And I'm going to go through a few slides first, and then Saifa is going to talk you through a little application that you could follow along. So I want to start with the cloud with a few links for the hands-on bit of this talk. So if while I talk, you could already get started with this. So sign up for a cloud account and download the data. I'm sure you're going to share these links in the chat as well.
Yes, Ali is going to
Yes.
share them in a bit.
Okay, great. And what I'm going to talk about is building fair and explainable AI pipelines. And before I start, a little background about myself. I'm Margriet. I'm Dutch, so I'm from the Netherlands, but I've been in the UK now for nearly 10 years, and I work as a data science and AI developer advocate for IBM. And previous to that, I used to work in academia as a climate researcher. So it was a bit of a switch, using a lot of big data and of observations and climate models, and now all about data science and AI within IBM. And so this is what I do now. I do data science, AI, machine learning, data. I said that before, and all in the cloud. And if you want to learn more what we do and the things we write, that's all on developer.ibm.com. I'm really interested in the fairness of AI and explainability because things seem to go wrong quite often at the moment. And this is just a really recent example from the UK, where because of the lockdown, a lot of students couldn't do their exams. So they decided to build an algorithm and have the algorithm decide what their grades are. And as you can see in all these examples, just from a few sites, it went wrong because a lot of students' grades got downgraded. So when they were supposed to have an A, they got Bs, or even worse. And this was very biased. So in the very expensive school, I think they're public schools in the UK, they actually get upgraded. But if you would be in a different school, then depending on the school where you are, you get downgraded. And of course, there was a lot of chaos around this, and they decided to even scrap the whole algorithm. So this is an example where they built a model, they used it in the real world, and it completely did not go wrong. And I think they could have avoided this by already even just looking at the data and already realizing that depending on which school you are, this gives a bit of bias. So that's not right. So I think AI is used in many applications to make important decisions, and they really also influence people's lives. So if you want a credit, if you want to get some credit, so get a loan, for instance, the way you get employed, a model might just read your CV, university admissions I just mentioned, and also in healthcare and even sentencing people to prison. So it is important to do it right and to do it fair. But first, what do I mean with AI pipelines? It's really what I've been doing a lot is just do machine learning, build an algorithm, play around with it, and then that is it. But it's not all, because you can, of course, have lots of different ways of doing things. You have the machine learning, you go design neural networks, or even look into natural language processing, and all these things together really are the artificial intelligence. So it's not only the models, it's also the whole system around it, the pipelines, the way to deploy it, how to monitor it. And that's pretty much what I quickly want to talk about a little bit. So if you have, for example, this credit risk model, it's very simple. You have a lot of data with historical loans. So we know, for instance, from John, his credit score, his age, his income, where he works, and he had a no risk label for these loans. So, and you have lots of this kind of data and lots of more variables or features, of course. You train the algorithm and you have a credit risk model. Pretty straightforward, simple example. If you then have a new applicant, you have the same kind of features, and you run it through the model, and you can tell them if they're no risk or risk. That's great, but if you wouldn't look at the data, if there would be any bias in there, or really explore what's going on, you might end up with results that you would never wanted. So that's important. And in this whole, how do I say, AI pipeline, there's a lot of different things, because you, of course, you start with the credit lender, which would be the customer you're building a model for. That's what they want to increase loans, reduce risk, and have lots of other requirements they want for their application. And then that goes to a data science team who has the training data. And then only these two things are really the model itself. The rest is all just a lot of apps around it and data pipelines. So in this case, then you have, of course, the data pipe streams, and then also you could monitor these things, which I'm going to come back later, with Watson Open Scale. So in this case, you can look at what the bias is and explain decisions to people as well. So in IBM, and this is a general pipeline, really, obviously, where you just get the data in, and you need to sort it and organize it, and then you could do that with knowledge catalog. Then you're going to build a model, and it does not matter where you do that, but you could do that, for instance, in a Jupyter notebook using Python or Spark, or Scala, or any language, really. And then this model can be deployed as an API. And the previous talk, that's a way to do it. You could do that also with lots of different ways. So Watson machine learning is also one of them, where you can then also manage the model and even retrain it quite easily. And then monitoring the model afterwards, once it's deployed, I think is a very important step as well, because things change over time. And you might, for instance, the quality of your model might just decrease. And what Watson Overscale, for instance, does is if it goes below a certain threshold, it will even then say, okay, let's retrain this model and see if we can get it any better and get the results better to what we want. But then, of course, you always have to keep looking at it yourself. You can't just leave this to this system only. A different way, what I said before, is it like this? So there's lots of arrows going all between all of these, because this is a system that never ends. You can't just leave it and build and run a model and that's it. So you have to go back, monitor, orchestrate it, retrain, get new data in, etc. Things like that. Then in IBM, all this runs now on Cloud Pack for data. And I wanted to mention this because you might know the IBM Cloud. And recently there have been a lot of new things coming on. So now you can run all the services, like all the Watson services, anywhere you want. So you can run them on your own network. You can even run them in AWS or wherever. And to make this all like completely integrated together, the cloud version of Watson Studio and all these other packages are now combined into Cloud Pack for data. So the names have changed here and there in the user interface, but this is why. And this is all runs on Red Hat OpenShift. But that's just a little bit of detail that if you're just working as a data scientist, you shouldn't even have to worry about these things. It's just great that it will run everywhere in the same way. Would be easy. So this is pretty much how it looks, the whole overview. So you have, of course, the infrastructure, then the layers of where it runs on, then the cloud packs, and then most users, you only come into the advanced technologies, so where your different applications are that you're using. For instance, Jupyter notebooks will be in that layer. And as I said before, this is pretty much all you can do now. Doesn't matter where. So in this case, we're going to use the cloud pack for data as a service, and this has all these different building blocks. So you can look at your data, build models, and then from deploying and monitoring all the way down. So that's pretty much the AI pipeline. But what I also find important here is to keep things fair and explainable. And that's also, as I said before, with the A-level grade in the UK over the last week, doesn't always go right. Well, there's a few more examples where it didn't go exactly right. So, for instance, last year, Apple introduced a credit card, and the model they used to approve the people to get the card also didn't work very well, because even though they thought we're clever, we know that probably women will get less approved than men, so we take out the feature completely. And that was not the smartest thing, because in this case you would still, because all the other features were still so correlated with the gender, that it still came back, so women didn't get approved. And I haven't found anything if that's still a problem or not. But yeah, that's another example. And then also Amazon tried to run a very biased model for reading CVs, and then the number one in the US is an important example where people got classified for higher risk, just and it was very biased towards darker people and women as well. And of course, you've seen the GPT-3 model, the latest, which also seems to have a lot of bias, which all comes from the training data. So I think this is just important to always think about when you're building models, like what is in the data, how does it work? And there's lots of open source tools available to do this. So you could have a look at, these are all Python packages. And if you go through any of these links, there's lots and lots of demos and examples there. So you could look at did anyone look tempo with my model? This is very important if you're looking, doing visual recognition, for instance. This really goes into how to avoid, if someone just adds some noise to your picture, how do I pick that up and protect my model against that? I'm going to show you a little bit in a second about the AI fairness tool, which is all about the bias in models. So this is a package that has lots of metrics that you can find, explore the bias in the model and in data, and also then correct for that. And then it's also important to be able to explain your model. So why is my loan rejected, for instance? How can I make this better? And these kinds of algorithms are all in the AI explainability tool. And it's also important to know where your model comes from. So it's easy to download the Tensorflow model, but who built it? What did I train it on? When? Which version was used? And for that, it's really important to have like a metadata around where your model came from. So this is all about the AI fact sheets. And then we're gonna talk a little bit about Auto AI later, which makes building a model super easy. So instead of having to write lots of Python code using scikit-learn or Spark or any other language, you just upload a CV data file, and it gives you a model and deploys it. Husseifer comes back to that, so I'm not going to talk much more about this. What I wanted to do is just want to give you a little tour of Watson Studio, how to run a Jupyter notebook, and how to deploy a model and then monitor this model in Watson OpenScale. And there's two links here, because this info, all what I'm showing is comes from two workshops. So the first one is the AI Fairness workshop, which has a notebook in there. I'm going to show you that, but then you can later have a look at it as well. Still working on this, so it will change over time, because I haven't gone through all the possibilities and options in this package yet. And the other one is a large Git book, which really goes through the whole pipeline of building a model, deploying, and then monitoring it. And to get started with this is the link to get a free cloud account. I signed up yesterday to try out how quick it was, and it only took me a few minutes, so that was pretty quick. So you get you go to this link, fill in a form, and then you get an email with that will give you a confirmation number, and then you're in, and then you end up with this screen. Can you see the cloud dashboard?
Yes. Can you please zoom in a bit?
Yes, of course. Well, I say that. It's refusing to zoom in.
Ah, that's interesting.
Let me try.
By the way, guys, I have created a poll. If you want to have a more detailed workshop about AI fairness and how you can build non-biased models, so please vote, and we can do a separate detailed workshop about it later on.
Yeah, don't know why it's not doing it. Let me. No, it's refusing. I'm sorry.
It's okay. By the way, guys, if you can see that the screen is blurry, you can always watch the recording later or download and watch it in HD. Right, thank you, Mark. Go on.
Yeah, okay. So this is the IBM Cloud dashboard. Once you've signed up, you end up here. You won't have any resources. So that's what you have to go and do first. So if you want to go, for instance, use Watson Studio, you go to here to the bottom on the right, top right, create resources, search for Watson Studio, and then keep all the defaults, and then you just get started. And then I'm just gonna, and then you have in the end a whole list of services here. Oh, well, I haven't logged in. You just have to believe me on this one, and then you go really easily to the Watson Studio, for instance, once you've installed it. Sure, if I can show this as well. Then once you end up in formerly Watson Studio, now IBM Cloud Pak for Data, as you can see here, you end up with this welcome screen where you can run Jupyter notebooks and do quite a lot of other things. Also, Auto AI, for instance, is part of this. So what you do here, it works really by creating projects. And within this project, you can then put all your notebooks, your data, your streams, you put lots of different things. So you just create a project and create an empty project, for instance, or you can upload a zip file. And I'm not going to do this. You just say test or what, it doesn't matter. Well, let me try to use, yeah, how this goes better. Good. And then you can, the thing is that if you do this for the first time, you will not see storage here. So you will have a link, something saying, can you please add some object storage to your project? And you just go again through the defaults. It's free. And then you have a cloud object storage, which looks pretty much the same as Amazon buckets. So I have one already, and I have, of course, a test already. I have a test one. I say create, and then it creates a project for me. And I have many already, so I just go to the next one. This is one of the projects as well, where I have, this is the first page you will see. So it has what is it about, how much data am I using, and how many assets and collaborators I have. So in the assets, you can find the notebooks that I have, because I have imported many of them already. These are Jupyter notebooks. And there's a few more interesting things in here, is the environment. So you can just decide, there's lots of different ways to configure the kernels. So you have choices here. Do I want to use GPU, or do I want to use Spark, or Scala, or Python? And then there's also choices on how much CPU and RAM you want to use. So if you have a lot of data, you just need to go for a little bit larger. And in the free account, you get 50 capacity unit hours, what I call them, for free. And then you just use these up. So the smaller really you choose, the longer you can use the free capacity hours. And then deployments, you can just have jobs, and access control is where you can add collaborators, which is quite a cool part, I think, because now here I can just add my colleagues to it, and we can work together on the same thing. So what I wanted to do now is to add to this project is a notebook. And as you can see, if you click at the top, I did that maybe too quick, add to project, it's a giant blue button. Well, I can just add data. So this could be data files, CSV file, JSON, zip files, anything really. I can create connections to databases. Here I can build dashboards quite easily, or add Watson machine learning, which I said was used to deploy your models. And there is streams, and now you can do decision optimization, which I haven't even tried yet. And as I said, the Auto AI experiment is in here as well. And then adding a notebook is quite simple. You just go here, add a blank one, add one from file. So you just upload one locally or from a URL, which just normally how I use it. I have my notebooks on GitHub and I just upload them in here. I'm not going to do that now because I have them already. So that is one of my projects. I wanted to show you an actual notebook. So a Jupyter notebook, this runs in Python, as you can see. And this is from this workshop I mentioned earlier of removing unfair bias in machine learning. And for this, it's really fairly simple. I just install Line, which is great open. It's a package where you can just really try to understand and explain your model. And then again, I also need to install AIF 360. So I'm not going to run this now because I've been out of here. Sometimes if you run the cloud, the kernel dies, so you have to start over. And it's quite simple, importing some pandas, NumPy, and Seaborn to do some visualizations, and then build a model with scikit-learn. I'm not going to show you all the steps here, but just kind of the general flow of what I've been doing. And I'm going to use a data set, which is about credit. A data set, so if people get a loan approved or not, and it's from Germany, but it does not really matter. So I'm using the AI 360 package, and it's quite simple. I have to first, because I'm in the cloud, I have to first do a little bit of fiddling. So I need to get the file through an FTP file site, and then put it within this path, because that's how they set up AIF 360. But it's quite simple. You just have to add, find where your Python is living, get that location, and put data in. So download it, put in the right bit. So now load the data set. It's quite simple. And the data format is interesting because it is very similar to how scikit-learn does it. So it is pretty much a class with NumPy arrays or pandas data frames within them, and quite a few variables. And in this case, in this example, I'm going to look, the label is defined as credit, and the protected attributes in this case are the sex or the gender and age. So I know that this data set can be biased based on gender. So if you're male or female, or an age. So younger people seem to get loans less. And then exploring the data, I'm just going to skip over this one, like which features are in there, what the labels look like. And just these are very basic pandas little scripts. And what is the cool thing here, I'm sorry for scrolling so much, is exploring the bias in the data. So now we get into this AI fairness bit. So in this case, we're going to define that we're going to look at the age as the privileged and unprivileged groups. So people over 25, they're privileged, under 25, they're unprivileged because they just get less loans. And we're interested to see if there actually is anything like that. And within the package, there is a lot of metrics and algorithms that just easily calculate these things. So you can look at the mean difference, so which is the difference of the rate of favorable outcomes received by the unprivileged group to the privileged group. And it's pretty much all, you compare the percentage of people who get a loan between the different groups. And this could be a percentage, a difference, or just added up and divided by stuff. And that's pretty much the difference between all these different metrics. So the mean difference is this. So yes, the younger people do actually get less loans, and then there's loads of other ones. And if you now build a model, and this is just a simple example, so build a model with scikit-learn, a very simple logistic regression. I just have to get the model, I standardize the features so they're all having the same distribution, and then do a prediction and look at the model. So the accuracy of the model is this, and the confusion matrix is this. And I'll come back to that this is in a second, because if you now, we know there is bias in the data, and if we take this out, so we can do that here, we can transform the data. So we reweigh it, which is part of the AIF 360, based, so each row gets a weight, and then we fit these weights, and then we transform the data set. And as you can see, if you then again calculate the mean difference, so this was the original and then the new one, it becomes 0. So we have a slightly different data set now with different weights. And then you can use this reweighted data to retrain the model. So it's exactly the same way, just the data has different weights. They come in really in the fit here by the weights. And as you can see, the model got slightly better, but it could be anyway. You change them, but it's very similar, so that's great. And the cool thing here is that it's not much. This was the new model, this was the original model, and you can see if you go from here to there, we have 2 more younger people approved for loans. And that's just by changing the input data a little bit. But you could also do this within, there's an algorithm to do this within the model itself while training, and also afterwards. So after training, you could still correct for bias. And it really depends on what you want to do here, of course, because you just basically trying here to keep it fair for everybody. I don't know how I'm doing on time, but if you then deploy,
Okay, yeah.
if you could then deploy, for instance, this scikit-learn model, or in this case, just an example with a Watson Spark model. I can have a model here. I'm just going to show you this. So I just loaded a pre-trained model with Spark. I trained the model, and then you can deploy it quite easily from your notebook straight to Watson machine learning. So I have quite a few models here. They're same data, so German credit risk models. They are APIs now, and they're deployed as an API over here. And in the other link I sent in the slides, you can see where it goes, and then you can quite easily just check. Test the API. So I'm just going to put some values in, and this is what comes back. And what you then can do when you would use this API in production in a real, in an application. Oh, this always happens. I don't know why. You can go to open. Very interesting. You can link this to OpenScale, which doesn't want to work anymore. I've had a few problems this morning. Let's see what happens. And if it doesn't, then I'm just going to show you some screenshots. But yes, so once you deploy a model, you can configure OpenScale from a notebook, which is in the same notebook I was showing before. And then you end up with this kind of cool dashboard where you can just look around and all your models. So in this case, I have 2. I have, again, the German credit risk model, and this one is from the notebook I just set up, but I haven't configured it yet, so it doesn't show anything. So over time, it just in real time, just keeps checking your model. So it looks at my quality. So it looks at the fairness. So it looks at age here. So you can see the fairness score is 100%. So it is good, I think. But as you can see, there's a red label for the gender, and it's not, it's below. So we can do something about this. And why is this? And in here, you can just then click around and add, just configure the monitors, I think it is. Yes, so it tells you where it comes from. And drift, we can look in, for instance, so does the model go down over time, and and how much is it used? And in here, you can also then look at debiasing. So in the background, it uses the same AAF 360, for instance, where you can say, I want to improve my model. There's a lot of bias in it, and it will automatically train it for you, and then create a second API. So you can then compare the original model against the unbiased model straight away from in here, which is quite a cool thing to do, I think. And that is all I had to say. So that was the whole pipeline very quickly. So all the way from getting your data in, building a model in a Jupyter notebook, and then deploying it and looking at it through OpenScale. And I think we should go back to the hands-on right now.
Yes. Margaret, so there's a question: at what scale OpenScale performs ETL operations, and how many types of data are supported? Does it support OWF, OWL, RDF, JSON in a single framework, or one needs to transform it first?
I think the API is only accepts JSON, but I am not sure. And yeah, because in OpenScale itself, it's only doing the monitoring.
I think he meant Auto AI, maybe not OpenScale, because we just talked about Auto AI and OpenScale too, so they might have gotten confused, I guess.
Yeah, I think Auto AI is only CSV, but I'm sure Saifa knows better.
Okay, he'll cover this, I guess. Right. Thank you, Margaret.
You're welcome.
All right. So I think a lot of people have showed interest in doing a detailed workshop regarding fairness and biasness in models and how to work with that. So I guess we will do a detailed workshop later on. Thank you, Margaret. So I would like to announce Josefa now to conduct a detailed hands-on workshop on the topic so that you audience can get more insights about how everything is going on, how it works. Right. Thank you.
Okay. So just introducing Josefa. Josefa is a developer advocate at IBM dedicated to enable enterprise and local developers on the latest data and AI tools. So I welcome Josefa to the stage and show what Watson is up about and how it can help people to implement machine learning.
Thank you, Mesum. Okay, so hello everyone. First of all, before I proceed to the hands-on part, I would like to share a few things. First of all, the developer advocacy team has been organizing a lot of workshops and webinars all over the world. I would request Ali to share the meetup page for the Middle East and Africa region. So that would be good if you want to learn about new technologies by IBM as well as the open source. It would be good to keep an eye on the meetup link. So let's proceed to the hands-on part. For my hands-on, I have a rather something that will require, I would say, no coding experience and no coding as well. So let's just create a new project in IBM Cloud Pack for data. Dr. Marguerite showed you how to create a project, so we will just start creating a project. Let's click create a project. We don't have any sample files, so we will create an empty one. So let's just name it anything you want, but just however you're comfortable. And this shows that we don't have any storage service associated with the project. So whatever data or whatever asset that you will use in your project, it needs to reside in some form of storage on the cloud, right? So let's just add the storage. And it's showing us that it's already selected the light plan, which is free. And it gives you up to 25 gigabytes per month. So this plan is already selected. We will just click create. By the way, I would just like to check if I'm audible and if you can see my screen.
Yep, we can see your screen and we can hear you perfectly as well.
Perfect. Okay, so now it's showing me it's asking me to refresh the page. Now you can see that it's showing me that the cloud storage has been associated with the project. I have named it. The description is optional, so it would be okay if you don't put it in. Now let's click create. I hope that you have downloaded the dataset that was shared by Ali in the chat, because we will have to use Auto AI to predict the churn classification. So before I will talk about the use case, but let's just go to the settings first. This is basically our project dashboard, and as we want to do something related to the machine learning, we will have to add a machine learning service. So when we go to settings, you will go to the associated services. You can see that currently we don't have any. So let's just click add service and Watson. Now we want to add machine learning service, because this service is actually the one that will provide us with all the algorithms and all the machine learning frameworks like Keras, TensorFlow. So it's already selected as light plan. We get up to 8 cores, up to actually 16 cores and 64 gigabytes RAM. And it allows us to deploy 5 machine learning models. That's actually free plan. So let's click create. My region is already the one which is selected for the Cloud Pack for data. So I would like to keep it like that for reducing latency. The service name is fine. You can name it if you want, and then we will click confirm. So Auto AI, the tool that we'll be using today, it actually automates your whole AI lifecycle. So whenever you have a problem, let's just talk about our case. We have a classification problem. So we have a sample data set that has the records of customers, and we want to identify if the customers are a churn or not. So the churn customers are the ones that are most likely to leave our network. And so if you want to predict whether a customer is churn or not, that is a classification problem, since we will be classifying a customer into a churn or not a churn. So Auto AI actually does that for you. If you just want to, you just have to input your data set, and then it will automatically do all the data pre-processing. It will make all the pipelines for your model. It will actually choose the best performing model for you as well. And then you just have to save it and then deploy it as a model. And then you can use it in your application, or you can use the endpoint URL to basically score that API, like to score that model. So I'm sure that you are familiar with this add to project thing. Dr. Margaret explained it very well. So we will be just adding the Auto AI experiment. You can see here. So now let's just name it. It still doesn't matter whatever you want to name it. You can see that we have the machine learning service associated with it, and then we have the compute configuration. So for the free plan, for the light plan, it's actually giving us 8 cores and 8 virtual cores and 32 gigabytes of RAM for our machine learning workload. So let's just click create. So once it's created, it will ask us for the data source, as this is the only input that we have to put. So I'll just browse for a file. I hope that you have downloaded it already. So we have this file, and let's just open it. So it will read the file, and it will automatically detect if it's a classification problem, if it's a regression problem. We can change it if we want to play with the experiment settings. I'll just give you a brief overview of the settings as well. So now it's asking us, what do we want to predict? We want to predict churn, which is the last attribute or the last column. So let's just click churn, and now it's showing us that it's a binary classification. If it's a yes, then yeah, it's a churn, and then we will be like the metric that we will be using to actually rank the best model or the best algorithm would depend on the accuracy, like how much accuracy does it have. We have two options, experiment settings and run experiment. So let me just give you an overview of the experiment settings as well. So here we can decide our training data or hold our data split. We have our columns that we want to include in our prediction or in our experiment. Then we have the options for selecting the problem. You can see that it's already removed the option for regression, so that we don't do it by mistake, because it knows that it's a classification problem, so it could only be a binary one or a multi-class one. Then we want to specify the positive class. So that is yes, because the churn attribute, if you look at the data set, it's valued as yes or no. And then we have the metric we want to select. It's recommended that we use accuracy, since in our goal or in our usual machine learning workloads, we demand that the model that we're using is an accurate one, or it's at least the highly accurate one. Then we have the different suggestions for the algorithms that it's chosen itself. These are all the classifying algorithms, so we will just keep it like that. And then we can actually select that how many algorithms should it choose. So for example, we have selected it as 2, so it will take the 2 top performing ones, and then it will create 4 different models for each algorithm. It will do some feature engineering, it will do some hyperparameter optimization in the way. These two are really important concepts when it comes to data preparation, and also when it comes to model tuning. You can check it out later on, and there's a whole theory behind the parameter optimization and the feature engineering. And then we can select our runtime. So it's giving us the basic overview, like how many iterations will it take for the feature engineering and etc. So let's just click Save Settings, and we'll be back to the main page. Now let's click Run Experiment. This is a churn classification problem, but we also have a problem that is the same classification one, and it's about fraud prediction. So the one that that is similar to what Dr. Marguerite was talking about, that whether if we loan a customer, if we give, let's suppose if we give $1 million loan to a customer, whether it would be a fraud risk or not. So that is also a classification problem that will run same as that. So I would request Ali to share that link as well in the chat, so that you can experiment with it later on. That is a very detailed tutorial, so it would be good for you. Okay, so right now we have this main Auto AI page. On the upper end, that is with ship map, and then the progress map, we can actually see the progress of our experiment. I prefer the progress map since it shows me a tree kind of structure. So as I was saying, that it's selecting 2 models, and then it will create 4 different models for each algorithm. Some models will have optimization for one time. Some will have optimization twice and then feature engineering. Some will have all 3 of these enhancements. So based on the accuracy, it will actually rank the top performing one. And then we just have to save it and deploy it. It will also give us the endpoint URL, so we can call that using our Python API or Java or even curl command. It will also give us that one. I'll show you later on. So right now you can see that it has split up the data, it has pre-processed it, and then it is in the process of selecting an algorithm. So the top one, or the one of the 2, is gradient boosting. These, I will not go into the detail of these algorithms due to shortage of time. But yeah, you can always check out the documentation of scikit-learn or even these algorithms, they will be, you will find a lot of information about these. So you can see that it's actually created two models or two pipelines for us. And so far, the pipeline 2 has been performing well. I'm better since its accuracy is more, 0.805. And it will take some time, maybe just 3 minutes overall, but it will actually create 8 different models for you, and then it will rank the number 1. You can see that building just a one model took it like 24 seconds. So it's actually pretty fast. It's actually very time saving. And the top, I would say the most impressive feature of using this Auto AI is that, even if you don't have an expertise or, deep knowledge on different algorithms and what approaches that you want to take, you will still be able to solve a problem with very well approach using Auto AI. Because whenever you're dealing with a machine learning or an AI problem, before starting anything, you have to decide what approach do you want to take? What kind of data transformations would you have to do to actually get your required results? And selecting the best algorithm or the most optimal algorithm. What would be the tuning steps that you would have to take to increase the accuracy? There's a lot of different, I would say, there's a lot of knowledge that goes on behind solving a problem, but this Auto AI actually bridges that gap. So if you're a data scientist who is experienced for like 5 years, 6 years, or if you're just a data enthusiast who's trying to learn these things, it would be a good start for you as well. So right now it's performing feature engineering for creating the model 3, which is now created. So you can see that even if the model 3 was created, the pipeline 2 is still the better performing one. It didn't match the accuracy, or it didn't exceed the accuracy. So meanwhile, it's creating the pipelines. Let me just go to a pipeline that's already been created. And let me just show you how it looks inside. So it's giving us the accuracy. It's giving us some different terms like area under the curve, your loss, which is actually the opposite of the accuracy. So if your accuracy is good, then it means that your loss is minimum. Then we have an important thing that is confusion metric. So this shows us how well our model was performed or has performed. So in terms of pipeline 2, there were 468 records that were actually no, and it predicted as no. But then there were 50 that it predicted wrong, and then they were actually no, but it predicted them as yes. So they were not a risk, but it predicted them as a risk. And the same goes for the risk as well. So you can see that the purple box shows that it's less correct, like this standard is not good. And then there is more correct, which means that, okay, now it's performing good. It's just pipeline 2, and now it's ranked as second. So that means that we have a more performing one. Yeah, so we have the pipeline 4 is now the top of them. And it will create 8 pipelines, so 4 for each model. The second model selected was the XGBoost, which is also a gradient boosting, which is an advanced form of a gradient boosting classifier. And it will take the same approaches for creating the 4 pipelines for XGB as well. Oh, and by the way, if we just change this view, we can actually have a pipeline comparison for all of the pipelines here. This is experiment summary. If we just click pipeline comparison, it will give us the comparison, like how much better or how better have each pipeline performed. So you can see that the accuracy, this one is the top one. Yeah, so it's pipeline 4 that had the most accuracy, right? And but you can see that why it was suggested as the accuracy suggested as the metric, because you can see that if we had selected it loss, like the log loss, if we will select the model that has the minimum log loss. You can see that we have other models like pipeline 2 that has even lesser loss than the pipeline 4, but we selected the accuracy because we want to get the as much accuracy as possible. It depends on your problem, if your approach as well. Whatever you want to choose, you can basically choose on the basis of your metric. So if you have a problem that requires that the model that you will choose must have the minimum loss or the least loss, or maybe its precision should be the most, or maybe F1 loss should be minimum. So that depends on your problem. So we have created 6 pipelines, but up till now the pipeline 4 is winning.
Huzafa, you have like 8 to 9 minutes left. So maybe in the meantime, your pipeline is building. You can share something else, maybe your slides.
Sure. I would go to. I would like to show you something impressive. So here we have the developer site for IBM. I was mentioning the tutorial for the fraud prediction that was also about Auto AI. So that was also based on, or that was also published on the developer side. This site is actually a really good resource for you in terms of, you can see that we have these as well. So this is the tutorial that Ali has shared with you. You can take a look at it in your personal time. It also gives you both approaches to solve the same problem using Auto AI, but then it also gives you the approach to do it by using a Jupyter notebook, like through coding. But you can explore that later. So I will just meanwhile the pipeline is building, I will give you an overview of this website. So you can see that we have, like on this website, we have a huge developer community who are publishing different articles. They are publishing different code patterns, tutorials regarding AI, analytics, maybe Node.js, blockchain. So let's just click on AI, let's say. And then you can find out a lot of other tutorials, blogs, articles. You can see that we have courses as well. By the way, that reminds me of something that IBM has also collaborated with Coursera, and they are giving a free month. I'm sure Kamar will share more details later on. So yeah, make sure to check that out as well. So we have different podcasts, we have tutorials. Let's just click on tutorials. So these tutorials are actually step-by-step instructions for you to follow. So for example, it will give you each step that you can use to do any use case or to use any tool. It's about a lot of IBM offerings as well as the open source tools as well, because I'm from the data and AI team. So for example, if in my terms, it has courses on or tutorials on Keras, TensorFlow, scikit-learn, Python, R, Spark. So you can find a lot of different things on this developer community or developer site. So I would suggest you to please visit it in your free time to learn anything new, or to it's always good to get something or to learn something new. Knowledge always pays off. Let me check if it's done. Okay, so it's in the time of building pipeline 7. I don't know if it's the fault with my internet or what. Right, so let me just take you to, okay, so we have opened the machine learning section of it. So you can see we have code patterns. So code patterns are actually a detailed documentation plus the code for your any use case or any problem. So don't so it's basically these things are not limited to these use cases only. These are just examples for you that you can do or that you can explore, but you can always use the same implementation or use the same approach for any other problem as well, for any similar problem. And then we have, so this is the how it basically works. So instead of waiting for it, let me just show you how we can deploy it meanwhile. So for example, right now pipeline 4 has been performing the best, so we just have two choices: either P7 will basically outmatch him, or P8. But let's just suppose if it's pipeline 4, it's giving us the options to save it as a model or as a notebook. So if you're Python enthusiast and if you want to use the code, you can always save it as a notebook. It will give everything or every instruction in code. So I'm going to just save it as a model. You can keep it whatever the name you have, and then let's just save it. Also, pipeline 7 was built, but it's also not good as pipeline 4. So let's just create it in, let's just see in the project. I'm sorry about my internet. I don't know what's wrong with it since yesterday. Okay, so basically it's giving us the different, information for our model, and it's showing us that our model is not deployed yet. So let's just click on add deployment. You can name it anything you want. I'll just name it as a churn predictor, and it will be saved as a web service. So let's just save it. Now, once it's ready, it will actually be showing the status of initializing, or it's like the ready. So let's just go back to the project, and let me show you another way where you can find the deployments as well. So this is our main project, right? It's showing that the AI experiment is still running because it's building the pipeline 8. But then we have our machine learning model that's also added in the asset now. And these are the deployments. So now you can see that our pipeline number 4 that we basically deployed is initializing. And by the way, you can also do two other approaches as well. I'll just take one more minute to explain it, and then we will end the hands-on part. So when you save your model and you somehow go back to the project, you can also deploy your model by clicking on the three dots or the menu on the model name. So you can also deploy it through that, and it will take you to the same page. And then we have our jobs. That's another approach. You can set a job or you can set a schedule to run. So basically, any model that you want to deploy or any notebook that you want to run, or maybe it's an SPSS flow. That's also another approach to to develop and deploy AI models. You can always schedule them for another time. So that's also another way to. Oh yeah, something is definitely wrong with my internet right now. Let me see if it allows me to go inside the deployment. Oh, thank God. So it is allowing me. Okay, so let me just show you the endpoint before I complete the hands-on part. So this is the endpoint, like this is the URL that you will hit to use in your application. And then we have the ID as well. You can get it here. And then it's also giving us the code snippets if you want to use it in our code. So we have the curl command. It's showing us the input that we will have to use, and then the URL that we will have to basically hit. It's also showing us the code snippet. Come on. For Java, JavaScript, if you're a fan of JavaScript. For me, it's Python, so it's also showing me that. And then if you are a user of Scala, then you can use that as well. So if you want to just test your model as well, you can always go to these inputs where you can put your records. You can use this method as well as a JSON array. So it's your completely it's your choice if you want to use any one of the facility. And then if you click on predict, it will give you the result whether the customer is churn or not. Yeah, so thank you very much. That's all about Auto AI, and it's just a use case. I would highly recommend you to explore more use cases as well. So you have a better understanding of how you can furthermore use Auto AI. Thank you very much.
Thank you, Huzafa. So, Huzafa had a webinar as well in which he discussed fraud prediction using AutoAI in detail. I have shared the link in the chat. You guys can follow that too if you want to explore AutoAI in more detail. And one more special announcement I have for you guys. So, I have shared a link to create free IBM Cloud account. So, you have to create your account and follow Josefa's workshop that he has shared and email me a screenshot that you have completed the workshop. And after that, you guys can get 1 month's free access to Coursera to do IBM's professional data science certifications.
Awesome, awesome, awesome.
So this is special announcement for you guys. I hope you guys can do it. I'm sharing the details in the chat. And over to you, Misam.
Great. Thanks, Kamal. This is a very awesome announcement for the participants as well and those who are joining to learn and develop through IBM. So thank you, everyone. And thank you, Josefa, for speaking with us and showing us the awesome IBM pipeline, how it can deliver the data science application.
It's my pleasure, Mason. Thank you.
Okay, let me just share my screen.
Sure, no problem. By the way, guys, apologies that all of your questions are not answered on the call, but we are trying to answer all the questions in the chats because there are so many questions coming, so many comments coming on. And since it's an online meetup, we want to stick to the timeline that we have given you. So this is why.
Okay, so is my screen visible?
Yes, we can see it,
Okay.
but yeah, perfect.
So, following the Josefa, we are taking a short 5 to 7 minute break, and we would be right back to listen Mr. Taraj Shaukat about the power of AWS SageMaker. So, we're just taking a 5 minutes break and just join back the stream again. Thank you, everyone.
अभी हम सब जगह लाएंगे यूट्यूब पर भी आएगा
Thank you, everyone. Welcome back, everyone. And we would be starting the session in a minute. Talal, are you here?
Yes, I'm here. Can you hear me?
Yep.
Okay, great.
Can everyone confirm their presence in the comments if they are back? We are resuming up, so we don't want people to lose. great. So everyone is back. So we are resuming the session, and this session is all about the cloud itself. Likewise, the IBM was presented by Mr. Josefa and Dr. Margaret, and now Talal will be representing AWS platform. So Talal is currently working as a machine learning engineer at Azure AI, and he has over 5 years of experience. So I welcome Talal to the stage to represent AWS SageMaker. Welcome on board, Talal. You may now share the screen.
Thank you so much, Mesum. So can you guys see my screen? Mesum, can you see my screen?
No, I think I cannot.
Wait for a second.
Okay, now we can see your screen.
It's
No problem. I think, yeah. Move into the slide.
okay. Okay. So as you all know, this session is focused on AWS SageMaker. So I'll start with introducing myself. So as Mesum has already told that I'm Talal and I have worked for over 5 years in industry, and I'm working as a machine learning engineer currently, but previously I was working as a data scientist and data engineer as well. So because nowadays you have to work with big data, so cloud and machine learning goes hand in hand. So it's essential to learn about cloud if you want to excel in data science. So that's why I did my certifications in AWS. I did my certification in solution architect and machine learning specialty. So moving on forward, so the content of this presentation will be, we will first discuss why SageMaker is important for businesses, then we will discuss machine learning, Amazon stack, and afterwards we will see the introduction to SageMaker. I'll try to wrap it up as soon as I can so we can have some time for QA session. So before wasting any time, let's move forward. So why SageMaker? So SageMaker helps business in improving their customer experience. It helps them to make difficult business decisions efficiently. It also helps them to add new innovations to their business. So basically, Amazon provide different layers of machine learning stack. So the low level layer includes the basic ML frameworks, like they provide you with TensorFlow, PyTorch libraries or Keras libraries, and they also provide you with infrastructure, which includes GPUs, EC2 instances, or FPGAs, depending upon your requirement. And then you can also make use of some high level services, like if you are a person who don't know about machine learning or data science algorithms, and you are a developer, so you can make use of simple Amazon services, like you can use of vision speech services in your application. So I'll give you an example in the next slide. So let's suppose if you are running a business and you have a clothing shop and you want to build a chatbot for that site, uh, for a person who is non-English speaker. So you can just make use of these services which are in this slide. So what will happen is that customer will talk to the chatbot in any language. So what transcribe will do is that it will convert his speech to text, and then afterwards translate will translate that language to English, and then comprehend service can be used to check sentiment analysis on that text, or it can be also used to check using Lex, which is basically a bot framework, chatbot framework provided by Amazon. And lastly, you can use Poly to basically convert the text to speech. So this will give customer an experience like he's talking to a real person. So in this presentation, our core focus will be ML services. So in ML services, Amazon provides us with Amazon SageMaker. So Amazon SageMaker is a huge product, and there are many different functionalities provided by Amazon in SageMaker. I can name few of them. So ground truth is basically a technology which helps you to label missing data set, and then they provide you with different optimization technique. They provide you with automatically hyperparameter tuning, and they also provide you with automatically deployment to high scalable and highly available environment. So Amazon SageMaker provide, so these are few of the services Amazon SageMaker provide to machine learning engineers. So starting from first, so it helps customer because as you all know that 70% of your time is consumed by for cleaning and pre-processing your data. So Amazon SageMaker provide simple Python notebooks to clean your data. So you can create your own notebook, or you can create a pre-built notebook provided by Amazon. And then you can use pre-built models provided by Amazon. So these models, there are a few of them here, like k-mean clustering, principal component analysis. So these models cover almost all aspects. Like if you want to convert speech to text, you can use sequence to sequence model. Or if you want to work on time series forecasting, you can use DPA forecasting model. And then you can use one-click trainings, so you don't have to write a lot of code. You just have to click a button and it will train your model. And then you can optimize your model based on your with a single click. And last but not the least, you can use this Amazon service to deploy fully managed, highly available, and auto-scalable endpoints. So, so that's all from the presentation. Now I will move on towards the demo. Okay, so let me first of all give you a quick overview of the demo. So in this demo, what we will be doing is that we will be working on a Chicago traffic data set. So our input feature will include some address. It will include some other features, and the output feature will be the number of violations on that given day. So let me open my AWS SageMaker console. So can you guys can see the screen? Mason, can you see the screen?
Yep, I can see your screen.
Okay. Okay. Okay, so this is basically Amazon SageMaker basic console. So you can see that there are on the left panel, there are few of the functionalities, which few of the features like ground truth, we already have mentioned that. But in this presentation, I'm focused more on Amazon SageMaker Studio, which is an IDA sort of a thing provided by Amazon. So this is Amazon SageMaker Studio. So first of all, let me give you a quick overview of few of the functionality which is provided by Amazon in this SageMaker Studio. And let me tell you that this studio is currently not available in all regions. So right now it's currently available in few US regions, and I guess two in European regions. So currently it's not available in any closed region close to this Asia Pacific or in Asia. Okay, so here in Amazon SageMaker, currently we are in folders tab. So in file browser, you can see your files, all your notebook files and all other data in this folder. You can create new files, you can upload new files, or you can also attach a Git repository to it. So if you want to create a new file, the launcher will open. And so in launcher, you can select any container. So there are multiple containers. Let's suppose if you want to work on a deep learning TensorFlow model and you need a GPU, so you don't have to create a Kubernetes container. So Amazon provides you with the most common containers automatically. Okay, so then afterwards there are other features, like I'll move on towards the more those features which are used more. So this feature actually helps you to shut down any kernel or any job. So right now I have a kernel running, I have a terminal session which is running, and I have to I have a single image which is running on 2 GPU resource. So moving on forward, as we have already seen in IBM, there is a feature which is known as Auto AI. In Amazon, it's a similar to that Auto AI. It's an autopilot. So in autopilot, you just have it's just like you will provide your training and testing data to this autopilot, and it will generate models, and you can choose the best model. So let me show you the basic pipeline. So you provide Amazon autopilot with the raw data, and you specify the target column, and then Amazon autopilot will automatically generate a model, or it will generate multiple models based on the provided data, and then you can make modifications in that model. So it will generate notebooks, so you can alter that notebook according to your requirement. Okay, so so let me just show you the options here in autopilot. So you just have to write the name of your job. It should be unique in that region. Yeah, you have to specify your bucket in which your input data set is present. Okay, you have to specify the prefix of the input data set, and lastly you have to specify the output bucket and output prefix. Okay, and yeah, there is another option in which you have to select the type of the machine learning model. If you know about the type of the machine learning model, you can specify. But if you don't know the type of the machine learning model, you can just select auto, and Amazon then will automatically decide which type of model is best fit for this problem. Moving on forward, so this is for deployments. This is for endpoint. So right now I have an endpoint deploy. So this is showing my endpoint, and and you can also share your screens. You can also share your notebooks using this snapshot feature by just clicking on this feature, and it will create a snapshot of your notebook, and you can then share that notebook with any person. Okay. Apart from that, you can check your diff using this simple feature. So in this, now you can see that you can actually visualize your differences, like in this code, if there was any change from the saved copy and from the unchanged from the current copy. So it will tell you about those changes in diff. So moving on forward towards our problem. So in this problem, as we have, so I'm not going to execute this code because it will take time. It took me for like about 50 minutes to execute this code, but I'm just going to give you a quick overview of this code. So it's just a Python code. First of all, what we are doing is that we are setting our bucket name where our data is present currently. So then we are loading our data set. Okay, so this is the form of the data set. So we have filtered out few columns from our data frame. So currently we have address, violation date as an input feature, and we are going to predict violations on our output. Okay, so these are few of the visualizations. So it's simple. You can also visualize these kinds of visualizations in Python Jupyter Notebook. So it's just a Jupyter environment in Amazon SageMaker. And after that, we are splitting our data in our training and testing sets. And the thing which requires attention is here. So what we are doing here is that we are making use of Amazon SageMaker hyperparameter tuning. So what we are doing here is that we are not going to tune our hyperparameters manually, but we are going to use Amazon SageMaker automatically hyperparameter tuning functionality. So what we are doing here is that we are setting our range. Like we know that our ideal minimum batch size is between 100 and 200. So Amazon SageMaker will identify the best batch size. Similarly, it will identify the best epoch size, and it will also tell us about the learning rate. So we have to give an objective metrics as well in this case, because we want our so that Amazon will try, SageMaker will try to minimize this objective metric. So in this case, it will try to minimize the root mean square error of the testing data set. Okay. So after deploying our model, so there are different strategies you can use to you can use for hyper tuning. You can use Bayesian method, or you can also use a random search method. So right now we are using Bayesian method here. And after doing all this, doing your training, choosing your hyperparameters, now it's time to deploy your model. So you just have to write this code to deploy your model. And even if you don't want to write this code, I will show you another option in which you can just click on a button to deploy your model. So in this case, right now what we are doing here is that we are setting our initial tuner, which we built in the previous cell. So we are providing our endpoint with the tuner, and we are setting the instance size. So this is basically the hardware on which our job will be running, our model will be running for inferences. So that's all from SageMaker Studio, and now let's move on to the SageMaker. So in SageMaker, as I mentioned before, we can deploy our models by using just clicking a button. So here we have model. So this is my model forecasting DPR. So you can just click on this model and you can create endpoint. So I'm not going to create endpoint because it will take some time. So you just have to click on this button. But first of all, you have to specify the name of the endpoint, and you have to specify some configurations. Okay. So okay, after that, one important thing I want to discuss is the monitoring of endpoints. So let's suppose this was our endpoint which was deployed. So you can actually monitor your endpoint using this monitoring screen. So you can see the CPU utilization, memory utilization of your endpoint, and also you can deploy multiple variants of model on a single endpoint. So that's an important thing. You can discard any model if that is not performing well, and you can set the weight of the traffic to that specific endpoint. And let's move on towards the ground truth functionality. So okay, so in ground truth functionality, most of the time you are provided with data with a lot of missing values. So what Amazon SageMaker ground truth does is that it will create a job, and it will label your data based on other features. So let's suppose if you have a data set with images and you don't know about the label of the images, so you can fill all these things up, and you can choose image from the task category, and you can choose the type of the image you want to label. So let's suppose if you want to label uh, image, if you want to use single label, so you can use this checkbox. Or if you want to use multi-label, like in this case you want to identify if there is a human, vehicle, or animal in this image. So for that purpose you can use this image classification technique. This will also work for text, and this will work for videos as well. So it's an amazing feature provided by Amazon SageMaker. And after that, okay, so you can also monitor your training jobs. So you can let's suppose let me see if there is any training job here. So yeah, so let's suppose if I was running a training job, so it will show me the status of their training job. In this case, I executed this job before yesterday, and I know the duration of this job. I can see more details of this job by just clicking on to the link, and it will show me all the details of this job, including the output. So let's move on to the output. So yeah, this is the output of the job. So by clicking on this link, it will show me where the model of this job is present. So after that, you can also use pre-built model, like AWS Marketplace provide you with a lot of models. Few of them are free, but most of them are you have to pay for those models. So you can use those models according to your requirement, and you can also publish your model if you have built something you feel like is worth selling. So you can sell your model here. And then I feel like that's all from my side. If you guys have any questions, so I can focus more on that specific area you need me to focus on.
Okay, thank you, Talal, for your wonderful session. So, questions. So, one of them is AWS certification free?
Is AWS certification?
Free.
No, AWS certifications are not free. So, but there is AWS provide you with tokens. So let's suppose if you clear one certification, then in the next certification they provide you with 50% off coupon. So they give you incentive on clearing certifications.
Okay, great. Another question is, if we want to try your workflow, can it be accessed remotely, and what kind of credit it will take to execute?
Sorry, you cannot get my credentials, but I can share a repository. This is basically a Amazon Labs repository. I can share this in comments, so you can get a SageMaker code from this repository, and you can try and test on your own.
Okay, great. One of the last question is, can you share your LinkedIn profile as well so people can connect?
Sure, I can share it with you in the comments.
Okay. Thank you, Talal. Thank you for joining. Let me just share my screen.
Thank you, Mesum.
Had a wonderful experience with AWS. So it's a very, very powerful cloud platform that enables many of the giants such as Netflix and many other platforms as well.
Yeah, thank you, Mason, for having me here. Thank you so
Thank you.
much.
Okay. So next to Talal is joining the Google platform, right? So we have top platforms here in our conference right now. We discussed what IBM has to offer, what AWS makes a difference, and now we are talking about one of the biggest platforms, that is Google Cloud Platforms. So to discuss these platform, we have Mustafa Ali from Exclusive Solutions Private Limited. He is a computer vision engineer, so he would be demonstrating you computer vision API on Google Cloud Platform. Followed by him, he would be passing the torch of the Google Cloud to Ms. Aksa Kausar, who is ML engineer at Red Buffer, and she holds a title of Google Development Expert for Machine Learning, and she's the only female GDE in Pakistan for machine learning. So this is our honor to have both on the stage with us, and I'll pass the torch to Mustafa to gradually introduce himself in the presentation.
Hello, Assalamualaikum. Can you hear me, Mesum?
Yep, we can hear you.
Thanks, Mr. Mesum, for the introduction. Myself, Mustafa Ali. A little about myself. I'm certified professional data engineer with the Google Cloud and GCP machine learning specialist. Currently working as a vision engineer at Exclusive Solution. Can you see the presentation?
Yeah, I can. People can comment in the session on the Facebook, YouTube, and Crowdcast if they can see the screen.
So these are the key resources. And moving on forward, today we are going to demonstrate end-to-end machine learning pipelines using Google Object Detection API and deploy our vision project on GCP. A little about GCP is where we can deploy our applications, Google Cloud, and big data machine learning capabilities. You can check cloud.google.com for more information. So taking our machine learning model to a production level, Google AI platform provide us easy for machine learning developers, data science, and data engineers to take their machine learning model to a production level, which is quickly and cost effectively. Google Cloud also support Kubeflow, which is an open source platform which let you build portable machine learning pipelines. As you can see, there are machine learning activities and GCP service according to the activities. To ingest our data, we have transfer services, cloud storage. To prepare our data, we have cloud data prep and data procs and cloud data flows. To pre-process our data, we have cloud data flow, cloud data procs, and BigQuery. To discover the data, we have AI hubs available. And to develop our model, we have data labeling services, deep learning, virtual machine images, AI platform, notebooks. To train, we have AI platform training, Kubeflow, and test and analysis, we have TFX tools. To deploy our models, we have AI platform, prediction, and Kubeflow. If you're familiar with data engineering on GCP, here's the architecture where we can store our data sets, databases, and service-based processing. We have AI and pre and post-process services. The data flow solution. And if you want to build your own model, we have Cloud Auto ML, where we can use pre-built vision APIs, cloud speech-to-text API, and other services. You can see the console. Everybody can see. Okay, so today we are creating an object detection API using TensorFlow. So this is the Google Cloud Console. All. Activate Google Shell. Check our okay, so my account is set up. And check our project. Yes. So a little about TensorFlow architecture overview. We will use TensorFlow 2.x, an open source machine learning library, and we will use object detection API, open source framework built on top of TensorFlow 2. We will use pre-trained object detection models, which is object detection API provided pre-trained models. And if you don't want to build your own model, you can use pre-trained object detection models. We have two types of implementation: local implementation and remote implementation. We will do a remote implementation on Google Cloud platform. Here we have five pre-trained models available, which are SSD MobileNet, SSD Inception, RFCN, ResNet model, faster RCNN ResNet model, and faster RCNN Inception ResNet model. First of all, we will launch Compute Engine VM instance. We'll create new instance. In machine type, we will select custom, number of cores 4, 8 GB of memory. Will allow our HTTP request. In networking, we'll set external API. We will create a new API, static API, and reserve. Static API 1. I've already named static API, so that's why we are having issue to reserve with same name. Done and create. So it will be ready in few seconds. I've already created an instance, so without wasting time, we will move on. Okay, so switch to a root user. Now we will install object detection API libraries. Since I've already installed, so it will take less time. Now we will install Tensorflow 2.0. We'll have to install object detection API. We'll clone the library. It's already exists. Now, now we will have to download our pre-trained models, which are binary files. So we will make a directory and moving to M folder. As I told you earlier, we have 5 models, which are SSD MobileNet, SSD Inception, RFCN ResNet, faster RCNN, and faster RCNN Inception. So I'll load these all models and we will use one by one. Each model has their own limitations, so you will have to know which model is perfect for your so it will take a bit. So we will use our faster RCN and ResNet model. If you want to use any other model, you can simply change now we will install our web application. To install our web application, we will change our directory. I've shared the link to clone these repositories. Now, TensorFlow object detection example directories already exist, so I'll just create object detection service. Service is created. Now I have to reload it. Okay, so default the username is username and password is pass0 rd. So if you want to change it, we can modify by changing in decorators.py file. We'll enable our service and start our service. So our service is started. To check the status of our service, we can check, and it says it's running. Okay, so what we'll have to do is to copy external link, and so username and password is. So this is our object detection API. I'll simply go to testing images and we'll test the image, upload it. Okay, so as you can see, this is our original image, and if you want to classify where the car and where is the bus, we will check another image, upload it. As you can see, there are few cars which is not detected, so we can change our model, so it will help. We can localize where the persons are and where the car. Similarly, on the other data set like this, upload. All right, so if you want to change our model, you have to stop this service. Write any model name. We will try SSG model. Load this. We restart the service and check the status of service. Service is running. Same. Upload our image. So This is our object detection model. And then these are the repositories I will share as well. And this is our instance. While making instance, you have to know about the working load and number of jobs you are creating.
Mustafa, sorry to interrupt. आपकी screen अटक गई लोग कह रहे हैं. आप please check कर लेते.
Okay.
Everyone, please comment if you can see Mustafa's screen comfortably. It's visible and not blur.
You can see the object detection model. All right.
Yes,
So
everyone can see.
if you want to build your own model, what you will have to do is to enable Vision API and create a data set. You can use a public data set or you can create your own data set. Okay. There is it. Okay. So as Salah showed, you have single level classification, multiple level on AWS. Similarly, a Google Cloud Platform provide this models. Single level classification, we have multi level classification, we have object detection models available. So we'll create a data set. You can import your data set from Google Cloud Storage, or you can simply upload your own models. Then you will have to train your models. Since we have no images uploaded, so it's just an introduction if you want to build your own vision-based model. In the previous webinars of Ramadan special series, I have developed the vision model, so you can check this out. Furthermore, the Aksa will continue about TensorFlow and Kaggle dataset building models on TensorBoard.
Hello and assalamu alaikum everyone. I hope you can hear me. If there's an issue, do let me know and give me a while to share my screen.
Okay, Aksa, I can see your screen. Can you share?
Hello?
Yeah, Aksa, you are audible, but we can't see your screen.
Just give me a second. I hope my screen is visible now. So just a slight introduction of myself first. I'm currently working as a machine learning engineer at Redbuffer, which is an AI-based services company. At the same time, I'm also a Google developer expert in machine learning, which in summary means that I work to basically build the community around me. I give workshops, I give talks, I write blogs, and they're all more or less related to machine learning. So today's session is briefly on TensorFlow and a couple of other things that you can do very easily in Colab. And Colab
So I'd start by one of the interesting things with Colabs is that you can very easily integrate it with Kaggle as well. And Kaggle is like the data hub of everything ML these days. There are a few steps that you follow. So you basically install Kaggle library. You have to make like a few files in order to host your key from your Kaggle account. So you do that. You make the JSON file. You set a few settings that are required, and then you're set to access anything as if you're right in your Kaggle account, right? You can list down the data sets that are available in Kaggle. So these are all the data sets. There's a longer list, so you can list down a subset of that. You can also maybe identify and say, okay, I just want to see the sentiment data analysis available on Kaggle. And then once all of that is done, you can just use your key and you can download any data set from Kaggle directly. So for example, here's a simple example of how I wanted to download a data set for which had images of malaria cells, so infected and uninfected malaria cells. And this is how I could easily just download that. So I'll get that right here in my Colab files directory. And I can simply unzip the data. So I wouldn't go too much into the details of how the code exactly is working, but just to give an idea of the some of the amazing things that you can do right here in Colab, right? So you can unzip the data, you can create directories as you like, and all of those are visible right here to you. And how? So here you can see that I have all the directories here of testing, training, uninfected, whatever kind of directory setting that I want. And here's a simple little into how the dataset basically looks like. So this is what the dataset looks like. So you have infected images, you have a few uninfected images with no spots at all. And one interesting thing that I can do directly here is connect my Colab to my Google Drive. This is taking a bit of a time, but I'll tell you what this initially does. It basically asks you for authentication. Once this has run completely, it'll ask you for authentication and basically ask for a code that you'll get through your Gmail account. You enter that here, and then you're connected to your drive. What that basically means is that you have your drive mounted right here. So if you can see, here's my drive, and I sort of also has some of the folders from my drive right here. And then you can save. You can also pick up data from your drive. You can save models to your drive, especially when you want to save, for example, checkpoints of your models, or you want to pick up a saved model and try that out. And it also helps in ways where you want to share that model with other people. So you can play as much as you want in the Colab, save that to drive, share that drive link with someone else, and they can load it in their own Colab, etc. The model that is built is simple. It's just a few layers of convolutional neural networks, max pool layers, layers, etc. But what the point essentially, here's a small summary. So it's not a very complex model, but here's a summary of what it is. The number of total parameters, and there are about like 13,000 images per class. So 13,000 for uninfected and 13,000 of infected cell images. So once I have sort of like built the model, I can also use TensorFlow's tensor board in order to evaluate my model performance. And that's pretty simple as well. It's just like 3 cells here. So you load tensor board. All you have to do is basically create a callback for your tensor board. And the callbacks in TensorFlow are basically what they refer to is you sending feedback, data feedback to a service in TensorFlow, right? So you can have tensor board callbacks. You can also have early stopping callbacks. So early stopping callbacks would be if you want to, for example, stop your model after it has reached 90% accuracy, or after the loss has reduced to 0.1, things like those. And this is classification for whoever asked that. So this is a simple classification model, and you're classifying images into uninfected or infected cells, malaria cells, right? So what you do is you create a TensorBoard callback, and you pass that to your fitting function, right? And you can have a number of callbacks at one time as well. So you could have TensorFlow callback as well, you could have early stopping callback as well, and you could have a few other callbacks as well. You can also save your checkpoints, and you can have like a checkpoint callback as well. Okay, I want to save my model in my drive after every 5 epochs. So we already have a drive mounted, right? And if I want to create a checkpoint callback, this is what I'm going to do. So I'm going to define exactly where I want my checkpoints to be saved in the drive. So that's drive app malaria detection, the folder that I have in my drive, right? And I'm going to create a callback again. And then here the callback that I'm creating is model checkpoint. So I can sort of define, okay, I only want to save the weights. I don't want to save the entire model. Or I want to save it after every 3 epochs. So you can define the period as well. Or you could make it 5, or you could make it 10, depending on the sort of model you're building and basically depending on the complexity of the model as well. So these are hyperparameters that you're basically deciding yourself. So if I want both checkpoint callbacks and TensorBoard callbacks, so I'm basically just going to add another CP callback here as well. So it's going to call both, send data feedback to both of these services basically as it is training. So as your epochs are basically running, this is how, so you can write a small command to basically see how your TensorBoard looks like. And this is how it would look like. And you can see that it has displayed both loss, epoch loss, and epoch accuracy for me. The accuracy is increasing for each of these data points basically refer to one epoch, which is one training step over the entire data set. So you can see that it started off here. And it's also displaying when I ran this model, and with time the accuracy is increasing. And then finally, this is where I am. And similarly for loss, you can see the loss as well. And there are a few other things as well that come with TensorBoard. So you can also see your model here, like the entire look of your model, what it looks like. So there are dense layers, flattened layers, max pool, etc. At the same time, you can then save your models to your drive as well. You can directly do model.save as well, but I made like a small function because I was saving both checkpoints and the model. So I made one function up here, here. So this was saving both my weights and my model. And this is one bit of like a few bits of what you can do in Google Colab. Now, one interesting thing that I want to share in the little time I have is with respect to explainable AI. So I introduced that like a tiny bit. And if you find it interesting, please go back and definitely look deeper into this. So so initially, over the past few years, we have seen that there has been like a change from heuristic and rule-based machine learning to linear models, deep models, and then meta learning. Meta learning is where you have a model that's creating another machine, right? And with time, we've also seen that as the complexity has increased, it has sort of like become harder for us to understand what the models are doing and why they're doing what they're doing, right? Something that is more commonly being referred to as a black box now, right? So explainable AI is basically the process of understanding how and why a machine learning model is making the predictions that it's making. So for example, if I'm sending in an image of a malaria cell and the model says, okay, this is infected, then how can I understand why is the model calling this infected? What is the model looking at, and how is the model looking at this to classify it as a malaria infected cell and not an uninfected or a normal cell, right? So that is what ML explainability, the gist of it is. And Google Cloud Platform basically now has something that's called explainable AI. It's something new in Google Cloud, but it's something very, very useful. The features of explainable AI in GCP are increasing every few months, and it's an active area of research even at Google. So there are two things to it: the model builder and model end user. And both of the people who are building the model can benefit from this as well, and the people who are using the model can benefit from this as well. So for example, if I say, how does explainable AI look for image models? So if I have like an animal detection a recognition model, then this is what explainable AI is giving me as a result. So if it's classified as a bird, so the model is telling me, okay, these are the pixels in your images that basically gave a high signal for this being a bird. So it's identifying, for example, the beak of the bird is giving a high signal, and that's why the model said, okay, this is a bird. In contrast to this, if, for example, I had passed this image and it has said it's not a bird, or it was saying it's a bird and giving high signals of pixels in the background, then I sort of know that my model isn't performing well, even though it's sort of giving the right result. But this acts like as a debug tool to be able to say, okay, it's not performing well in the sense that it's looking at the background pixels and saying, okay, this is a bird. So when I have passed this to, you can work with explainable AI directly from your Google Colab as well. There are a few steps, projects, setup steps that you require where you're authenticating with your GCP, you're creating a bucket, deploying your model. Basically all the steps that were shared in the previous, right before I started. So all of those by Mustafa. So all of those steps can sort of be done directly from Google Colab as well through a few commands, and that's where all of this comes in. But I wouldn't go into the details of that. What I really want to share is that these are my images that I sent out to the model, right? And these are infected images, and they're I can sort of see, okay, these are infected, maybe because of these, but I really want to know what my model thinks about this. Why is my model calling these infected, right? So I can pass these on to my explainable AI predictions, right? So I can get predictions, normal predictions, but then you can also get predictions with explanations. So when you say with explanations, you're basically using GCP's explainable AI. And in that case, you can see here that it has sort of highlighted these areas for me, that these are the regions that gave me high signal that, okay, this is infected cell. And same for this case and this case. If I compare these to my images above here, so you can see that these were the areas that were basically correctly saying that these are infected images, right? And my model is kind of like correctly classifying the regions that are causing it to be an infected cell. So that's what this is. Explainable AI is not just for images. It's for both. It's for text. It can be used for tabular. It can be used for images. But the gist of it is to basically give explanations on why the model is performing the way it is performing. So for text models, for example, it'll highlight areas of, so it classified this sentence as an action sentence, and then it has given, highlighted these words that are making the model call it an action sentence, right? And classifying this as an action sentence. So you can use explainable AI not just to improve your model, but also to debug it in ways that you may not otherwise be able to debug. But at the same time, to be also able, and if it is performing well, to be also able to confirm and increase your confidence in, okay, is it really actually performing well, or is there some bug that's causing it to give high accuracy, right? And especially in cases where you have to pitch ideas to investors and they're always asking, okay, how well is the model doing? How well is it performing? And you want to be able to give them some info of, okay, what is your model really doing, instead of just giving them the result, okay, this is what accuracy I'm getting, or this is how the results are. But to be able to give more intuition into, okay, why my model is performing the way it is performing, and what is it really highlighting into, right? And I guess that's about it on my end. And just a little overview of what Colab does and explainable AI.
Okay, thank you, Aksa. I guess if people have some of the questions with you to ask with.
Yes, please.
Okay, one of the question is, how is GCP explainable AI different from attention, CAMs, and grad CAMs?
So attention is it's a completely different concept. That's a concept on the model level, right? So having attention in a model, right? Is that what they're referring to?
Okay.
So that's something that's related to, if I got it right, I think they mean the attention in models, right? That's on the basis of how you're building the model, and attention is used in with respect to, okay, which feature of your data set you basically want to put more attention to, and that's something that has improved model performance. So it's something with respect to building the model, whereas explainable AI is something with respect to understanding the model. It's not something that's used to build a model in no way, but it is something that is used to understand why the model is performing the way it is performing. And there's a whole theory of shaping values and game theory. It's actually based on the interesting game theory, and to give you an idea of, okay, why is your model making the predictions, making which pixels is it focusing on when it says, okay, this is a cat or this is a dog, and to be able to debug that model better.
Okay, great. So if I can summarize what Aksa is saying, so Aksa, you can correct me if I'm wrong, that the model should be explainable, and that's what Aksa has told. And when you find the explainability to be on the side that you think that the model is not focusing on the right things, then you can give attention to CAMs and grad CAMs. So you can stress over what model needs to stress upon and what it needs to leave. Similar example works in NLP as well. And if you have a sentence and then you need to get different things out of this sentence, so you need to tell the model what should be in its attention phase and what should not be. So generally, attention is also a great chapter in LS teams as well.
Yeah, so basically explainable AI is a tool in on GCP, right, that you can integrate with the models that you're deploying on GCP. So for example, I am deploying this model here on GCP, and I can add explainable AI to this, right? So I will be able to, so I define my, so I've defined where I'm exporting my model in GCP, right, to the right bucket. And then I am defining the explanation meta, right? This is what I'm going to send to my explainable AI tool on GCP. So I'm defining what my input layer is and what my output layer is, right? And then I am basically I am defining which kinds of explanations do I want. So there are different kinds that you want. Some are better for text, some are better for images. So there's ID explanations, and then there are XR AI explanations. So I'm defining all of those, right? So my explanation method, for example, here is integrated gradient. So that's one method. And then it could also be XRAI, right? This is a different method that's used for explainable AI, right? And I can define these different methods, and then I can send requests to my models, and I can say, okay, predict for this image, right? For example, right here it's done. So I can say, okay, predict. I can pass the explanation meta file, and then I can say, okay, predict for these images. but also tell me, also give me explanations on each of those images, right? So you're using not just your model deployed in GCP for predictions, you're not just using Google AI platform, but you're also using the explainable AI tool on Google Cloud Platform. Let me also give in I'd also link you to a session that I recently did. The video for it is on YouTube for those who are interested. And I've given more detail into what exactly explainable AI is for each of different images, texts, tabular data, etc. So this is a very nice tool on Google Cloud that can be used. Yeah, that's about it.
Sounds good. Great. Thank you, Aksa, for joining us and sharing your valuable knowledge. And we are very proud of you to be the GD from Pakistan.
Thank you so much. Thank you so much. Pleasure is all mine.
Okay, so we would be taking just a 10 minutes break, and at 5:30 p.m., Scott is joined us. He's waiting for you all. Scott is a data scientist at KNIME, and he has joined directly from US. So we would like to thank Scott for taking out the time on the day of Saturday, especially for our community. And we would just like to take a 10 minutes break. And as the break is over, please be on time so we can resume the session with Scott. Okay, so we are planning to resume, and let me know in the comments section if you are back into the session. Hi, Scott. Are you available as well?
Yes, I'm here.
Okay, sounds good. Let's wait for the audience to again come up, and let's then start.
All right, just give me the green light whenever you're ready.
All right. So people are like, I guess we should start the session now. Yes.
Okay, sure. So just let me give a quick introduction to Scott. Scott is a data scientist at KNIME, and Scott is a wonderful champion of KNIME Analytics platform. He teaches machine learning and data science stream of the KNIME workflows. He actually enjoys letting people know how great is KNIME. So over to you, Scott. Have a great session with the amazing audience.
Okay, let me make sure everything gets turned on here. And screen shared. All right, so hello everybody. Can you see my slides here?
Yes, we can.
Thank you. Okay, excellent. So as Mason mentioned, my name's Scott Fincher. I'm a data scientist on the education and evangelism team here at KNIME. And what that means practically is I go around kind of doing talks like this and workshops with folks to help them understand how to use our tool, because a lot of times people aren't familiar with it, haven't heard of us before. So what I wanted to do today is talk to you a little bit about KNIME, both the company and our software is where we'll start. And then I wanted to show you a demo of the software uh, using the airlines data set for some classification modeling. And I'll walk you through how we can do, using a graphical user interface and a low code approach, some loading, transformation of our data, do some visualization, and then also build some different models and compare how they all work together. If we have time at the end, I can also show you a little bit of a deep learning demo with Keras, which we can also we could build neural networks in KNIME using what we call nodes without any code. We almost certainly won't have any time for the text analytics demo, but I leave the slides in here in case that's something that you're interested in. If you do NLP or something, you can see what our examples are. And then we'll have time a little bit at the end for some questions, I hope. So let me start first off, for those of you who are not familiar with KNIME, what is KNIME? So uh, KNIME, the company, we were founded back in 2008, so we've been around about 12 years now. Uh, we were founded in Zurich, Switzerland. That's where our headquarters is. We also have offices in Constance and Berlin, Germany, and more recently, about 3 years ago, an office in Austin, Texas in the US, which is where I'm based. And so as a company, we have two different pieces of software that we maintain. One is the open source KNIME Analytics platform, and that's what I'm going to be showing you today. It's free to download. We don't put any restrictions on the amount of data you can process with it or anything. And it is a comprehensive tool for loading data, processing that data, doing transformations, visualizations, analyzing, testing, training, and deploying models. So the key to KNIME is that it has this visual front end, which I'll show you. Everything's GUI based. And you can blend all sorts of data, everything from local flat files on your machine up through stuff that you may have in a database or pull from a big data setting somewhere. And we like to integrate with other open source tools since we're open source. So tools like R, Python, H2O, and Spark, all of which I can show you today, to be able to pull things in from other tools you may already be using. We've been doing biannual or twice a year open source releases since 2006. We generally do a release in the summertime. We had one just about 6 weeks ago, and then we also do another one in December. And we're really committed to the idea of open source. You can always, if you want to understand how one of our particular algorithms works or something, you go out to Bitbucket or GitHub and check the code yourself. And when we release extensions, we release them under the open source umbrella so that it's not something that you're having to download and then pay for things. You're getting it for free for the KNIME Analytics platform. And often that leads to the question, well, how do we keep the lights on as a company? How do we pay the bills if we're just giving away free software all the time? And the answer to that question is we do have another product called the KNIME Server, which is our commercial offering. And the idea is if you're an individual data scientist or you work maybe on a small team using the open source KNIME Analytics platform, um, you can use it free, you can do whatever you need to do, but there may come a point where you need some additional features like being able to collaborate and exchange workflows with the folks on your team. In particular, being able to do version control, being able to schedule and automate deployment of models. That's where the KNIME server comes in, and it's aimed at companies and more of an enterprise. So we sell that software, and that's how we pay the bills, so to speak. The KNIME server also allows you to build workflows, and then you can make them available to other folks like business analysts who haven't seen KNIME at all, um, and execute those workflows via a web portal. So that's the concept of guided analytics, being able to put a product that you've built in front of someone who doesn't necessarily have your knowledge of KNIME, but still for them to be able to use it. A dashboarding approach. That's something else supported on KNIME server. And again, this is something that we've done several releases for going back to 2008. But enough about the company and all of that. This is what KNIME actually looks like, and I'll show you some more of this when we walk through the demo here in a little bit. We basically go from left to right. We bring in these little colored boxes, which are called nodes. We connect them together to build a workflow. And then, maybe you do some visualizations along the way. So if you're new to data science, or maybe you're not new, you may have seen R.A. Fisher's iris data set, which is what this plot is. Everybody's seen this plot a million times probably. But all sorts of visualizations that you can do. So we'll look at some of those in the demo. Um, the idea of KNIME, the kind of building blocks of how it works, we use these nodes. Here's a group by node up here at the top. So the data flows from left to right. It comes into this little triangle, which is an input port. Something happens within the node, and then it flows out on the right. That's the output port. And then we have this little traffic light at the bottom, which is a status indicator that, if it's green, yellow, or red, gives you an idea of the status of the node. If it's green, it's executed, you're good to go. If it's yellow, you need to change some options. If it's red, something has gone wrong. So we take these nodes, we connect them together on these branches to build what we call a workflow to build out our task. And you can see all these different colors. These different colors represent categories of functions in KNIME. So generally, the reader nodes, wherever we're going to be reading in data, that's going to be orange. Blue nodes here are going to be some sort of visualization. Yellow nodes are for transforming. Green or for building models and applying them, and so on. So we have this color scheme that kind of helps you understand when you're looking at a particular part of a workflow what it is exactly that you're trying to do. And then ultimately, we also have a feature called components. So I could take this entire model building workflow and condense it down into what we call a component. It's a way to encapsulate complexity in a workflow that you've built, and also a way to share functionality with other people. So maybe I wouldn't boil my whole workflow down into a component, but maybe I have some document pre-processing steps in an NLP context that I constantly am doing. Things like removing punctuation and stemming my words and stuff that I do every time I read in some text. I could condense that into a component and then share it so that other folks on my team, or even I could publish it publicly, folks throughout the world could use that. So you could think of a component like as building a little function or a library in a coding sense. So this is what things generally look like. Just kind of wanted to introduce you to those concepts so when we start walking through the demo, you'll already be familiar kind of with how things flow. So this is kind of a marketing slide, really, just to show you all the different things KNIME can do, all the way from, as I mentioned, reading in data from different sources, whether that's local or databases or even big data, Hive, Hadoop, Impala, doing transformation with these yellow nodes, right? Row, column, matrix transformations. Um, Analyzing data. This is where I think KNIME is actually really strong in this green section in the middle, because we have a whole bunch of different model algorithms to bring to bear on your data for whatever type of problem you might be looking at, whether that's classification or clustering, image processing, text analytics. We have nodes for all that sort of stuff. Blue nodes for visualization, whether that's exploratory or diagnostic visualization, and then deployment. Maybe ultimately I'd like to build some sort of automated report to send to my boss, or write out a model somewhere to use later, or write other flat files. Ways to get data, you know, that you've analyzed back out of KNIME somewhere else so that other people can actually make use of it. This has over 3,000 native and embedded nodes included, which seems to me, I think, a little intimidating. If you've never used KNIME before, you may see that number and think, how in the world can I learn 3,000 nodes? Like, that's ridiculous. And what I would say to you is, don't worry about that. You can be very effective using KNIME, um, using a very small subset of those nodes that are particular to the task that you're trying to do. You may only need to know 15 or 20 different nodes, for example. I certainly don't know all 3,000 myself, not even close. So, like I said, this is more of a marketing slide, just kind of show you the different things that KNIME can do. So, if you are listening to this and quickly becoming bored and falling asleep, then that's fine. I would encourage you to go and download KNIME and play with it, because it's a lot more interesting to try it out than it is probably to listen to me talk sometimes. If you want to do that, you can go to KNIME.com and click on the big yellow download button on the top right-hand side of the page. As I mentioned before, it's completely free, no restrictions on the amount of data that you can process with the analytics platform. We also have some other courses out there available to um, help you learn to use KNIME in the context of kind of beginning data science sort of stuff. One that we offer on our website, and another one that we've put together and put up on Udemy that's mostly video content. It's about 4 hours of video content. We also have some books available via KNIME Press, one of which I'll give you a code for at the end of this presentation. So you could download the book. It comes with exercises and workflows, just a way to cement kind of what you're learning as you go. Okay. Oh, one more thing, I guess, before we get to the demo, the hub and the forum. So we have a website out there, the hub, it's hub.knime.com. This is where you can get access to different workflows, to different components, to different nodes. So uh, folks in our community, as well as folks on the KNIME data science team, upload workflows for different use cases, right? Maybe you need to start working on a churn prediction sort of example, right? And instead of starting completely from scratch, you can go to the hub and find one of our existing churn prediction examples, download that. It's going to come with data, and then you can start playing around with it, get an understanding of how the workflow works. And once you know that, then you can swap things out with your own data set and start applying and doing what you need to do. So we have all sorts of different example workflows for you to explore, as well as components and whatnot. So um, check that out at hub.knime.com. Then at our forum, which is at forum.knime.com, we have a really active user community that is available to help you out with your questions. I myself am also on the forum almost every day, trying to help people, work through problems with their workflows, or there's a bug, or why isn't this, doing what I expected it to do. Our community is really great, so I encourage you to check that out as well. Okay, enough of me blabbering about slides. Instead, let's look at a demo so you can actually see how the tool works a little bit better. So the first demo I'm going to show you here is a classification modeling demo using the pretty well-known airline flights data set. You may have seen this data set on Kaggle or some other places. What we're going to be using is really a combination of a couple different data sets. So one is from the US Department of Transportation. It's on-time statistics data from 2009. And what that contains is a bunch of information on different flights going from airport to airport throughout the U.S. Information, how long was it in the air, how long was it taxiing on the ground, which carrier is it, which individual aircraft was it, all sorts of information like this, just about planes going to and fro from these different airports. And the other data set that we're going to combine with it is some meteorological data from NOAA from that same time period. So, um, is it raining in Chicago? Is it sunny in New York, right? What's the temperature? That sort of stuff. So what we want to do with this data is we want to try and predict departure delays for these aircraft. So given what we know about these things, can we predict whether an aircraft is going to be delayed, where we define a delay as an aircraft leaving more than 15 minutes late? So to go through this process, I'll show you some basics of how we load and transform data in KNIME, and then also some simple visualizations that we could generate in KNIME, also calling in R and Python where we think that that might be helpful. And then we'll build several different models. We'll use several different algorithms, but we'll also use some of these other open source integrations that are available too. So you see them listed here. These are all pretty standard classification algorithms, but we'll use Python, R, H2O, native KNIME nodes. And then if we have time, I'll show you a little bit about logistic regression running on a local Spark cluster. And then ultimately we can see how all these models perform and compare the results. So let's switch over to KNIME and actually look at this. So here's the tool itself. Before I dig into what's going on in this workflow, I'll just show you a little bit about the interface. The top left up here is the KNIME Explorer. This is where I have all of my different workflows and workflow groups for stuff that I've been working on. I also have connections to the hub that I mentioned before, as well as a KNIME server that I'm connected to. Down here in the bottom left is the node repository. This is where all the nodes live. So if, for example, I want to read in an Excel file, let's say, I can go to the IO section of the node repository, go to read, and there's the Excel reader right at the very top. I also could have searched for something, like if I want to read in CSV files, I can type CSV, search for the CSV reader, and I can see a couple of different ones pop up. So there's many thousands of nodes here in the node repository organized by the type of task that they're supposed to perform. Then on the bottom right here, this is our console. So this is just going to give me in real time as I execute my nodes, warning messages, error messages, and so forth. You'll see this kind of change as we look at some of these results of things. And then on the left-hand side over here, the right-hand side is the description pane. So this is context-sensitive real-time help for any nodes that I click on. So I'm clicked on the Data Explorer right now. It's going to tell me all about the different options available with the Data Explorer, as well as the input and outputs it expects at its different ports. If this was a particular algorithm like the random forest, it would probably also have links in here to the paper that the algorithm is based on, so I could dig in and do some more exploration. So that's kind of a quick 2-minute tour around the interface, but let's actually talk about what's going on in here for a second. So on the left-hand side, and let me blow this up a little bit. On the left-hand side, I have this gray box here. This is called a meta node. It's a meta node because it actually contains other nodes inside it. So to go inside this meta node, I can just double click on it, and that's going to open up for me a different tab with some other nodes and other meta nodes. And so you can see I have some of this annotation, these colored boxes, and I have descriptions below each of my nodes. You can think of this as like comments that you would write in code, right? Whenever you have a GUI tool like this, it's a really good idea to add these types of annotations and comments so that later on you can understand what it was that you were doing, or if you hand this off to someone else, right, they can understand what you're doing. Starting at the very beginning here, we have this table reader file. This is where we're reading in this airline data set. So whenever I have a particular node, I can always do a couple things with it. I can double click on it to see its configuration. So for the table reader, there's not much to configure. I basically am just pointing at a file on my local system. This contains it contains the data itself, but then also things like headers and variable types and whatnot in a table format, which is KNIME's custom kind of internal format. This could just as easily be an Excel reader or a file reader or something else. And then once I have configured this node and executed it, I can always look at its results by right-clicking on the node, going down to the bottom, and looking at the tabular view. And so this is where I can see, okay, inside my data set, for my flights, I have year, month, day, departure and arrival times, flight numbers, taxi time on the runway, weather delays, all of this sort of stuff is in here. So then let's say, maybe the next thing I want to do is some sort of transformation. So I'm using this yellow transformation node in this example to convert my strings to a date and time format. So if I look at the configuration of this node, since it's doing something different, the configuration is going to look different too. So in this case, I'm taking my date here that's in string form. I want to convert it to a date and time so I can do some other extractions on it later. Um, I tell KNIME, here's what the format is. I execute the node and run it, and then I can look at my results. I'm not going to walk you through every single one of these nodes because we don't have time to do it, but I wanted to point out just these first two because this illustrates another, I think, important concept of KNIME, which is this. At, at every state in your workflow, you're able to see what your data is. So after I apply, for example, this very first transformation, just converting my strings to a date and time format, I can go in and see, okay, what did I do? I can look at the output table, go over and find my date and see that, okay, now it's actually is in the proper format. I can look at the column up here and see it has this little calendar icon, which indicates that it's now a native date and not a string anymore. What KNIME is doing is it's saving the state of your data at each point in the workflow. And why that's important, right, is because you can easily think of cases where, I joined some data sets together, but I joined them on the wrong key, and that's why everything downstream looks weird. I need to go to this part of my data blending node and make that change, right? I only have to go back to the part where the mistake happened, fix it at that point, and then when I execute it, I only have to worry about the stuff that's downstream. All the stuff that's upstream is going to, be the same. So it helps me in troubleshooting and fixing bugs that I may have introduced into my workflow. But also, it's just nice to check periodically at points along the way. What's the current status of my data? What does it look like? So there's other things going on here. We do some things like filtering of data, applying some rules to label our data along the way, do some renaming. We do some blending here on taking the meteorological data and bringing it in together with the existing flights data using a joiner. Some of these typical ETL things that you would do as part of cleansing and manipulating your data prior to doing some modeling. This is all stuff we can do in KNIME here. And this workflow is publicly available, so you can explore this later if you have time. So let me get on to the next bit here where we're actually building some models. So um, if we take what's coming out of this data processing node, I have 3 output ports. So I have my complete data set coming out of the top. I have a training set and a test set on the bottom. I split the training and test set using the row splitter because we're going to take the first 15 days of January 2007 as our training set and then the latter half of that month as our test set. That's maybe not normally how I would partition things. I might usually use a partitioning node to split the data. But here, since it's kind of time series data, that's why we're doing it this way. But I also wanted to just keep the entire data set on this top port here to show you some of the visualizations we might do. So for example, all of these blue nodes up here, these are doing different things. I have a node here in KNIME called the Data Explorer. If I look at the results of it, I can see at a glance what's going on with my numerical and nominal features in my data set. So I can see, what's the minimum, maximum, mean, standard deviation, all the way out to the second and third moments statistically, if you care about that. As well, more interestingly, probably the number of missings in my data, the number of zeros, and I even get a little histogram on the far right-hand side that indicates, skewness, which I may care about for some particular features. Maybe I want them to be more normally distributed or something. I can see that at a glance. So this just helps me as I look down through my data set to see what the distributions are for my numeric values. I also can see for my nominal values, how many unique values I have. KNIME is highlighting this for me. For example, the tail number of my aircraft, I have more than 1,000 different unique values for that. that's probably an indicator to me that this is not something I want to use in a model, right? This is not going to be useful. I should clean this out. So I could look at things using the Data Explorer. Now, I may also instead want to look at my data using visualizations that I prefer from R or from Python. And this is where the other kind of open source tools can come into play. Maybe I want to generate a pairs plot in R to look at how the meteorological variables may correlate with one another. So I'll show you the view first and then show you how it was built. This is a pairs plot where we're comparing, for example, snow depth versus maximum temperature to see if there's a correlation. And I can see at a glance, it gives me a little scatter plot. I see that there's a slope here, which indicates, there is a correlation, as you would expect, between snow depth and maximum temperature. And then I also get the slope of that line numerically up here in the top right. So, this is a view I could generate in R. And to do that inside the R view table, I can just write a little bit of code. And just 1 second, my electricity we have storms in the area, so there we go. I thought for a second the demo gods were gonna frown on me. Okay, so what we have here then in the configuration for this node is just a little bit of R code to generate this pairs
Scott,
plot.
can you zoom in on this because the window is so small I can't see anything.
For the dialogue, let's see, can I make this bigger? Unfortunately, I don't think I can. I'm sorry about that.
All right.
I should be running with a smaller resolution on my screen, I guess.
Can you use magnifier if you are running Windows?
Maybe.
I guess can be with bandwidth as well. So I'm turning off your camera, Scott. Maybe
Okay.
that will make the screen a bit better, not blurry.
I will say that the code here is not that interesting.
It's
It's really just a few lines of R that are generating this plot. And I just wanted to show you that it's
Okay.
possible. It's possible to, I could put this code in. I could run it line by line or section by section to generate it, and then I have a little console down here that would give me the results. I could do
Okay.
something
Great.
similar. I could do something similar using this Python view. Um, if I wanted to generate, for example, this is kind of a silly example, but a pie chart in Python, I could, import matplotlib to do that, write a little bit of code here to generate my pie chart, and then I get this rather silly looking pie chart. Why would you ever care about this? The flights by the day of week, right? So just to show you, again, the code that builds those is not very interesting. It's more to show you that in KNIME, if I want to generate this sort of visualization, I could do it with native KNIME nodes without using any code. Or if I do prefer to write some code because I have something that, already handy that I like, I could do that as well. So apart from the visualizations here, let me show you some of the models. So I have all these different models here. We don't have time to go through all of these, unfortunately. One is the KNIME decision tree here, the fourth one down. If I click on this meta node, I can go in and see that I have a decision tree learner and a decision tree predictor. So whenever we build models in KNIME, we have this learner predictor motif is what we call it. We always have a node that's going to train the model using the training set, and then a node that's going to apply that model to the test set using a predictor node. So to train a decision tree, I go into the configuration and say, what's the thing I'm trying to predict? In this case, it happens to be the departure delay, which is a 0 or 1 binary variable. And then I have other options for applying pruning and things if I need to do that. Once I build the model, and I could even visualize the model, the decision tree as well here if I wanted to by looking at the output from the learner, dig into the different levels of the decision tree. I can apply that model using the predictor, and I can even apply the columns with the normalized class distribution or the probabilities, which is going to be useful because ultimately what I want to do is look at the accuracy, how well this model predicted just from an accuracy standpoint, which I can get from the scorer. I can get the confusion matrix and accuracy there. But if I keep those probabilities set aside, I can also generate a ROT curve. And so that's what we're going to do for each of these different models that we build. So I can do that. This is all no code using the KNIME native decision tree. I also could do this in Python using, for example, a random forest. So again, here we have, even though we're using Python, we still have the learner and predictor motif here. So again, apologize for the really small text here. Sorry about that. But what's happening in the code is not much. It's just a few lines of code where I'm importing the random forest classifier from sklearn, and then I'm applying that algorithm over different vectors that I've identified in my input data set. So this is taking a KNIME table that we've already done the processing on as input, and then it's building the model using sklearn. And then we're going to take that model and send it to the predictor. Again, just a few more lines of code here to say, apply this previous model. Here's some different features that we can ignore, et cetera, and then see what our results are. And what we get out of that predictor node is a KNIME table that is going to have all of our original data set in it, which is fine, but all the way over on the right-hand side, the prediction that we're getting out of the random forest, as well as the associated probability. So again, we could look at the results of a confusion matrix, for example, since this is a binary classification problem, get an overall accuracy, and save those probabilities for use in a ROC curve. I know that I'm running out of time here, so I'm going to skip ahead just a little bit. What are the results if we were to do this? So we could build a model in Python. We could reach out to Python, have it do the model, and bring the results back. We could do the same in R. We could also use H2O AI. In this case, we use the gradient boosted machine. I don't know if you're familiar with H2O or not, but it's some algorithms that were built by some guys in Berkeley, California, that's highly performant. They run really fast and they scale really well. And we actually have a pretty tight integration with the different H2O algorithms within KNIME. They have their own nodes. We still have this learner predictor motif that I mentioned before. This section of the workflow looks a little bit different because you end up converting KNIME tables to H2O tables to actually have it do the modeling. But then we bring it back out to regular KNIME tables at the end to get the accuracy and ROC curves and so forth. So if you're familiar with H2O, as I mentioned, we have a really tight integration with them. So ultimately, what does this look like? If I want to look at the ROC curve, for example, I've combined all these different model results, and then I use a ROC curve node to plot it up. If you're familiar with ROC curves, then you know that what we're attempting to do here is minimize the false positive rate on the x-axis and maximize the true positive rate on the y-axis. So we're trying to pull these curves up to the top left-hand corner such that the area under the curve, the higher it is, the closer to 1 it is a good indicator that the model is performing well. Also, if you know anything about ROC curves, you know that this is a suspicious plot. These curves are too good. They're too far up to the left, and the reason for that is it turns out that when you're trying to predict airline delays, if you include the arrival delay for your aircraft as part of the feature set, then you can predict departure delays really, really well. So that's an example of data leakage, something you would actually want to avoid in your analysis, because you start to see suspicious things like this. But the good thing is we're not falling along the coin flip line, this 50% line. So anyway, I've got, Mesum, I think I have about 5 minutes maybe before questions, or you let me know if I need to stop and answer questions here.
Yeah, I think I would prefer if you can just skip to the questions because there are a lot of them.
Okay, so let me just wrap up then. I do have other sections here in this workflow that we just don't have time to discuss, unfortunately, but you guys can look at the slides later and kind of explore a little bit more.
Yep, that would be better.
So there's a little bit more on the Python integration. One thing that I did want to mention, because I think we have a lot of Python folks here, is you can actually you can call Python from within KNIME, as I showed you, but you can also call KNIME workflows from within a Jupyter notebook as well. When you make that call, you'll even see an image of the KNIME workflow here. So this is, if you like using Python and you want to work together with KNIME, we try to make that easy for you to do. More information here available for the different workflows that I've showed you. and I'll skip through some of this stuff on deep learning and text analytics. I wish we had time for that, but we don't. I do want to mention that we have available these books at KNIME Press. Please go out to knime.org/KNIME and use this promotion code Karachi-0820 for a free copy of the KNIME Beginner's Luck book, which comes with a bunch of exercises and will kind of introduce you to how we can, build models and do transformation of data in KNIME. The same code will also work for a 20% discount on our upcoming level 1 courses at the end of August and the beginning of September. So again, if you're interested in exploring more and you'd like some live instruction taught by data scientists on our team, then you can register for some of these. And having said that, I will stop here and take a look at questions if we have any.
Yes. So there's a question in KNIME, how can we add more than one data source? Like if we have 4 main files on which I'm going to train model.
How can you add more than one data source? Yeah, that's not a problem. I mean, you can add in multiple nodes, right? You could bring in this data pre-processing, I could have a table reader, I could have connections out to a database. I could then take that and have connections to, I don't know, Hive and Impala or something. I can blend data from all sorts of different sources and then join that together. So KNIME's actually pretty good at that. Incorporating data from different sources. I mean, if you have a question about a particular type of data source, I can tell you whether there's a node for that or how we support it. But generally, we're pretty supportive of different types of data sources.
All right. So can the nodes be customized?
Yes, if you want to do some coding. I mean, for the most part, we just make the nodes available. They're part of the software. People can grab them from the hub. But if you are fluent in Java and you want to write your own nodes, you can download our SDK and get writing if you want to. Yep.
Right. Perfect. Thank you. Thank you, Scott. Also, people are asking for the data set and resources. Okay, if you can please share that in the chat, that would be great. Thank you.
Yes, I will make all of that available in the chat here shortly.
All right. Thanks a lot.
Thank you, Scott, for joining us from the US, and we would really appreciate your valuable time on the holiday as well. And say thanks to Rosaria as well for connecting you.
Will do. Happy to take the time. Thank you.
Thank you. So moving on to the last and one of the exciting parts for every business developer and those who want to develop in a low-code library, a machine learning end-to-end platform. Please welcome Mr. Muiz Ali, who is a data scientist and founder and creator of the PyCaret, an open source machine learning library in Python. I personally know Muiz, and he is an awesome person, humble, and you would love to learn about the PyCaret session from himself. So I would like to welcome Muiz to the stage, and please share his screen and share his valuable knowledge around PyCaret with us.
Muiz, we cannot hear you. So you're on mute. Let me unmute you. Perfect. Can you please speak?
Can you hear me now?
Yes, perfect. But your video is like really blurry. Is there any better internet connection that you can connect to? Maybe data?
I'm using 5G.
Why are we still having that problem there? Okay. You can start just maybe zoom in a bit when you're showing code so that it's a bit visible to people. Okay, so I guess he's connecting. All right, perfect.
Can you see my screen?
Yes, we can.
Okay, so let me... Okay, so you can hear me and you can see my screen in full mode, right?
Yes, perfect.
Okay, so shall we begin?
Yes, absolutely.
Hello, everyone. Good evening, good morning, good afternoon. It's a very early morning for me here in Canada, but I realize people are joining from different time zones, so good afternoon or morning, wherever you're from. Hope you guys are doing well. Thank you for joining today. My name is Muiz Ali. I'm an analytics leader. I work for PwC Canada. I had Center of Excellence for North America, and I lead technical engineering teams. I'm a very passionate data scientist by night, very active open source contributor. Recently, I was working on a project for over a year, and in April of this year, we have open sourced it. It's named PyCaret. It's a machine learning library in Python, and this session is all about that. By background, I'm a chartered accountant, so I'm a member of CPA, CMA, CMA, but I don't practice accounting anymore. I have lived and worked in 3 different continents, and I have spent my career mostly in analytics and reporting in public sector organization. These days, based in Toronto, and in terms of situation here with regards to COVID, I think we are getting pretty much stable. Cases are going down, so we are hoping for the best that we'll be back soon, just like before. Okay, very active on social media. So if you feel like to stop by and connect with me on LinkedIn, Twitter, please feel free to do so. I'm also a very active writer on Medium. So here's my Medium link as well, in case you want to follow me there. Okay, some important links for PyCaret in our repository. So all these are links. All these links on the screen are really, really important. But the most important link is here, github.com/pycaret/pycaret-demo-IBM, because all the material, including this presentation and all the notebooks and everything else, is uploaded on this repo. So this is the one highlighted in yellow. This is what you need to clone if you want to follow along in the demo. This presentation is also included in the GitHub repo, so you'll get everything that comes with it, right? Okay, so before we get into the session, just want to make sure we only have 45 minutes today, but and we can only talk so much in 45 minutes, but there are a lot of resources on internet, and I have left few of them here, because you would get this slide when you clone the repo. You can actually go at your own time, go ahead and look at these resources. Some of them are notebooks, some of them are articles, some of them are video, but almost PyCarets integrate with almost every other BI tool, including Alteryx, KNIME, Power BI, Tableau, and there's a tutorial on every piece of it, right? So I'll leave it there. Okay, so let's get started. So this is the high-level machine learning lifecycle that I'm sure many of you are already familiar with. What we using PyCaret, what we would cover today is just this section on right, highlighted in red, which is basically training, tuning, and deploying your models in production. Whatever happened before this ETL pipeline and gathering your data and setting business objective, it's pretty much a standardized process, and every company would have different ways to handle it. What we are covering today here is this section only. Okay, so this is the high level diagram, but what I'm gonna do is expand it, zoom it in this section, training section, and basically go through a granular ML lifecycle, a typical supervised experiment. So you define your business problem, you define your machine learning objective, collect data, analyze. You split your data into train and test set or validation set. Then if you have any missing values in data set, you impute the missing values. You perform different kind of encodings. You perform different kind of scaling, transformations, feature engineering. You do other zillion things. And the reason you are doing all these things so that you can train a model, and then you tune that model, you track the performance of that model, you blend that, ensemble that, you try different things, and your objective is to basically find one best model that you can take and deploy in production, right? That you would use for inference. The problem is you repeat this cycle so many times because you don't actually going into the experiment, you don't know which algorithm or which model would work best, right? So you repeat this cycle many times, and you generate a lot of metadata as you are performing the experiments. All the metadata like model itself, metrics of models such as if you're doing classification, AUC, accuracy, recall, hyperparameters of model, number of iterations, and you also have to track them based on time as well, right? So you generate a lot of metadata, and in order to do that, you also write a lot of code. So what is PyCaret? So PyCaret is an open source which means free end-to-end machine learning library in Python that help you automate your workflows in Python. Right? It's easy to use, it's a productivity tool, and it's business ready. PyCaret can help you with data preparation, model training, hyperparameter tuning, analysis, selection, and experiment logging. And we would obviously, I'm running through it so that we can spend more time in the demo and have chance to answer some of the questions that you have today. So these are the things. At this time, we have the last stable release is PyCaret 2.0, and we support these 6 modules: classification, regression, clustering. So pretty much everything in classical or canonical machine learning. We don't support deep learning. We don't plan to include deep learning. Time series module is missing from this list, but it's already in development. So probably next 2-3 release, time series would be a separate module, as well as would be supported under regression module as well. Okay, so before we get into the demo, again, this link, clone this repo. If you want to follow along, all the notebooks and this presentation is uploaded there. github.com/PyCaret is our profile, and then the name of this repo is PyCaret-demo-IBM. If you are using or planning to use this on your local computer, local machine, then you need to do pip install PyCaret, either using Anaconda prompt or in the Jupyter notebook, doesn't matter. Installation may take 10 to 15 minutes. Okay, so before jumping into demo, I'll just pause on this screen for 30 seconds so that people who want to copy this can copy this. Or if somebody can actually copy this link and post it in the chat, that would be good. All right. Great. Okay, so let's move to demo. Okay, here is my. Okay, so here's my Jupyter notebook. I'm using it on my local machine, and if you are planning to follow along, this is the name of the notebook. There are 6 notebooks uploaded on the repo. I'm starting with this one, PyCaret 2 classification. Okay. Okay, so first chunk here from PyCaret utils import version. I'm checking the version of the library 2.0. Just want to make sure. Okay, PyCaret has a module called datasets, and in datasets module there we have a bunch of toy datasets that we have uploaded on GitHub. And for this demo, I'm using one of that dataset. So in case you want to check what are the datasets available on repo, you can check the index. And index has the listing. So each record here is a data set, and then you can see some metadata along with that, right? So the data set that I'm going to use today is this one. Where is that? Juice, number 14. It's a very small data set. It's a binary classification data set. So you have to choose between two type of juices based on about 15 attributes. Okay, so let me just load into the data set. So now I have this juice data set stored in my data variable as a pandas data frame. Obviously, when you're working with that, you would load your own data set. It doesn't matter how you bring in the data, either SQL or CSV. It doesn't matter as long as it's a data frame. PyCaret will work with it. Okay, so if you look at this data set, each row is a transaction in a retail store. And this is our target variable, purchase, CH and MM. These are 2 different type of juices. One is mango, Minute Maid mango, and one is something else. And based on all these characteristics, which is price of CH at the time of transaction, price of MM, the discount, loyalty index, sale price, store in which it was sold. Based on these attributes, we have to predict whether the customer would buy CH or MM. Right, so that's the objective. Anyways, any experiment in PyCaret starts with initializing setup. And when I say initializing setup, that means you have to basically initialize the setup by passing the data frame that you want to work on and the name of the target variable. So in this case, I'm passing data variable, which is actually this one, where I have my data frame stored, and name of target variable, which is purchase. All these things, I'll come back later, but you actually don't need it. You can just run it like this, but I'll come back to these things later. Let me first go ahead and just run it. And if you see this line here from PyCaret.classification import star, this is basically equivalent of importing everything in this module. PyCaret it's functionally typed language, so it is a little bit different than how you would write your code conventionally in Python. So it is different in that sense, but there is no harm in using this style of importing if you're working in Jupyter Notebook. Okay, so as soon as I run the setup, the first step is PyCaret would automatically infer the data types of all column. And why it is important? Because obviously there are certain pre-processing techniques that apply to categorical data differently than numeric data. For example, if there are missing values, techniques used to impute missing values for categorical data would be, for example, mode, or creating a surrogate column, or most frequent value, which is equivalent to mode. But if there is a missing value in numeric data, it could be mean, it could be median, or there could be also other techniques. But the point being that determining the right data type is very important. So the first step is PyCaret would automatically infer it. If these data types are correct, you can go ahead and press enter. In this case, I'm going to go ahead and press enter because I know these are correct. PyCaret would also go to an extent by detecting the ID column. So in this case, see the ID, it has been detected as ID column, so that you don't have to drop this ID column and then rejoin at the end of experiment. If PyCaret would detect ID column, it would basically not delete it from the data, but it would hide it from the data for the purpose of model training. Same goes for date and time. If we detect there are date and time in the data, what we would do is we would first of all, we would say it here that it's date and time, but we would also extract the features from that column, 5 or 6 or 8 features, and we would hide the date column itself for model training, because there's no use of using that in training the models, right? But in this case, you can see I don't have date time, so that's fine. But rest of the columns, so let's go ahead and press enter because they're correct. Okay, and as soon as I press enter, setup is completed. I can see the message, and I can see this big table here. This is my information grid. So anything that I did in setup, it would basically be, it will basically say here, right? So for example, if I read this table, if you notice that this is not encoded, right? This is CH and MM. This is not 1 and 0. So the one thing that PyCaret automatically did is encoded it into labels and have given you the map here. CH is equal to 0, MM is equal to 1. This is the shape of your data. PyCaret is telling you there is no missing values. There are 13 numeric features, 5 categorical features, and all these things, right? And then obviously PyCaret handles train test split automatically. So this one, so out of 1070 rows and 19 columns, your transform test set train set is 748 by 28 and 322 by 28. So if you sum up 748, 322, it would basically be 1070. And if you are thinking that original data had only 19 columns, why my transform set had 28? That's because if there were categorical features, PyCaret would automatically one-hot encode them. So you would increase the number of columns. There are other type of encoding available. If you want, you can do that. And these are all other pre-processing options. In our case, we haven't chosen to do anything. That's why everything is false. But to do anything, it's simple, because if you check the documentation of this function, all these are little switches of true and false. So if you want to do PCA, it is as simple as typing PCA is equal to true. That's it. Now you can see we have 2 columns only, because we one-hot encoded it, but we also applied PCA. So basically the sequence of pre-processing step is predefined, it's orchestrated, but you can simply choose true and false, and in some cases, some threshold. So for example, if you select feature selection is equal to true, it would also run classical feature selection methods. But if you want to restrict your space of features, you can pass a very aggressive threshold for feature selection, right? So there are almost 20-25 pre-processing options that are commonly used, that you can use them within setup. And what it would do is it would create a pipeline behind the scene, and you can use that pipeline when you are inferring your test data, or basically new data set in production, so that you don't have to manually not just manage it, but also manage the sequence of it, right? Okay. And also, I mean, if your data set is imbalanced, I'm saying because I get this question a lot, you can also fix imbalanced data set during setup function. You can just pass fix imbalance is equal to true. Okay. So once setup is done, so this process is common across all the modules. It doesn't matter you are doing classification, regression, clustering, anomaly, it's same. So, and the design of PyCaret it's not by fluke. It was intentionally made exact same so that you don't have any learning curve, right? Because there's no point of learning 3 different types of code, because at the end of the day, what you want to do is get a model out of it which can generate inference, right? Okay, so once the setup is initialized in whatever module, doesn't matter, the first recommended path we recommend is this function, compare underscore models. So very powerful function with just one word. What this function does is it would go back, check out the model zoo, and all the models that we have in model zoo, it would train them using 10-fold cross validation by default. And you can see interactively it's updating on your screen, right? So it's using HTML. And it would fit all the models. I think for classification, we have 10, I think we have 14 or 15 models, all the sklearns plus XGBoost plus SCATBoost plus LightGBM. And our plan is to not add more models, not to have a library of like thousands of models, because what we want is like you can use your own model in PyCaret. You don't have to use the pre-trained models from our library. As long as your algorithm supports .fit.predict argument, you can use anything. You can use them in PyCaret. Okay, so what this compare models is doing is basically comparing all the predefined models and checking their metrics using 10-fold validation only on train set, right? So this one 748, this is fitting all the models on the train set. Okay, let's give it a second here. Get boost is finishing, and by default it would return you the best model. So in this case, logistic regression, and obviously it is highlighting which model is best in which category. So you can see QDA is extremely good in recall, 76%, but obviously it is being compromised in terms of accuracy and AUC. So you can see respective categories, but logistic regression by default, it would take accuracy. So logistic regression is the best model. This table, if you notice, is sorted by accuracy, but you can change the sort order using sort parameter here. So you can say sort is equal to recall, and then if you do sort is equal to recall, I believe QDA would be the model coming on top, right? So by default, it would return you the model on number 1 position. So in this case, it is logistic regression. So if I check my best model, this is nothing but logistic regression, right? So dynamically, so if I were to do this, sort is equal to recall, the model stored in best model would be QDA, not logistic regression, right? So it's all dynamic. Okay. The other function that you would find yourself using a lot is the most granular function in PyCaret, which is called create model. So just by name, statement create means create a model for me. That means train a model for me, right? So, and it is as simple as just typing create model. And LR denotes for logistic regression, DT denotes for decision tree, RF is for random forest. So pretty much intuitive. But in case you wanna check, there is a function called models, just models. You can see the list of all models, right? So these are IDs, these are names, original implementation, blah, 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 right? Okay, so what we can do is just simply run this. What it would do is it would train this command here, would train logistic regression on 10-fold by default, and here are your metrics. So basically this line would match with here, and you can see it's matching 82, 63, 89, 56. So this is the same thing. This table is basically average tenfold for each of the model, and when you use create, you basically see results by fold. This is very important because sometimes you not only need a mean score, but if you want to check the stability of model, you also need the standard deviation, or you need to eyeball the results across the fold. So in this case, I can see, yeah, it's not a very good example to show you that, but sometimes it's really important you see the standard deviation too. Okay, so here I'm creating DT is a decision tree. If I want to create a 5-fold model, I would just simply pass fold is equal to 5. So in this case, you can see I'm training random forest with 5-fold. So you can see this is a 5-fold random forest, right? Okay, so that's just cross validation strategy. Is the same model. Okay. So you can also smartly use this models function, because PyCaret is functionally written. You can nest functions within each other, just like Excel, right? So if you can use this function very smartly by selecting a subset, which is select only ensemble models, and then you can smartly nest these functions together. So you can use compare models, whitelist is equal to models. So basically this command here is returning you list of these parameters, and then if you're directly passing it compare models, it would first create compare models. It would, just like Excel, it would execute the internal function first. So now it is executing this. First it executed this, now it's executing compare models, right? In the next version, obviously, we are adopting to the GitHub guidelines, and the parameter whitelist and blacklist has been renamed into include and exclude parameters. So the function is same, it's just we have renamed it to be more neutral. Okay, so just like create model, there's a function called tune model, which basically tunes the hyperparameters of model. In this case, I've created or trained a logistic regression model, which is this one, LR. When you do that, it uses the default hyperparameters. But what you want to do is also check the hyperparameters of that model and perform different iterations to see if you can improve the performance of the model. So there is a function called tune model where you can simply pass the model. So here I'm passing tune model. I'm just passing my logistic regression model. What it would do is, behind the scene, we have predefined hyperparameter search spaces. It would randomly iterate over it. And I think by default, it would iterate over it 10 times. And iter is equal to 10, but obviously you can increase it. And also, if you want to pass your own grid, just you can pass a dictionary of grid into custom _ grid parameter. By default, it is optimizing for accuracy function. But if you want to optimize, let's say, recall, just pass optimize is equal to recall. Now, this may result in a different model than what we have seen previously, right? Anyways, in this case, recall went up to 8253. Let me check if, oh yeah, so it actually went, so from 7262, it went to 82 something, right? And let me also check the difference, why it did that. So my default LR and my tuned LR, yep. So you can see my default LR with 72% in recall had a C is equal to 1.0, which is the default in sklearn. When I tuned it, it found this iteration, this 3.931 as the best in all the iteration. And this is not the guaranteed result. Like if you change the n iter to 25, this may further improve, right? Because you are actually increasing the number of iterations. In this case, it didn't. But if you want, you can do that. In future releases, what we are doing is also adding, because this is a random grid search. For next 2 releases, we are also adding Bayesian grid search, and we would also support the back end of tune model function would be just like a Spark. It would support massive distributed processing. So that would allow you to be able to tune, let's say, XGBoost on 70 million ROS. Okay, so just like create model, tune model, there is a function called ensemble model, which basically ensembles the multiple model together. So in this case, I am creating ensemble model on top of decision tree. And if you check bagged DT now, this is nothing but a bagging classifier, which is wrapping my decision tree inside, right? So you can see 85% in AUC for ensemble decision tree, bagged decision tree. But if you were to just see the normal decision tree, like one tree, it would be 75%. Normally, any tree-based model would improve performance during ensembles. Similarly, instead of using bagging classifier, I can do boosting trees. So in that case, I would just pass method is equal to boost.
By the way, there is a question here that which version of decision tree is used here, ID3, C4.5, or CART, or any other variant?
So it is a straight implementation from sklearn.
All right.
Okay. Okay, so just like so ensemble model is for bagging and boosting, but there are other ensembling techniques that you can use. So for example, blend models would create a voting classifier. So in this case, what I'm doing is, can you mute your mic? I'm hearing echo. Great, thanks. So in this case, what I'm doing is I have created a back DT and boosted DT, which is nothing but a wrapper around my simple decision tree. Here I'm blending them together. So I'm just passing these two in the blend models function. And let me show you when I run that. My blender is basically nothing but a voting classifier that wraps all these algorithms, right? Now, what you can also smartly do is, instead of running, you don't need to hard code this, right? This is just an example. What you can do is you can do this, compare models and select is equal to 5. So what it would do now is it would first run the internal function, which is this one. This function, compare models and select is equal to 5. By default, compare models return the best model. But when you pass the n select parameter, it would return a list of top 5 models on whatever category. So if you want it based on recall, you would also pass this, right? So when you do that, it would execute this function first. It would return a list, and then it would execute this function, right? So all being dynamically. So whenever you change your data set, now n select 5 is different. But again, it would dynamically do that. So you can create like a workflow that would work with any data set. Similarly, stack models. So if you don't know blending, when you take a soft vote or hard vote of estimators together, but stacking is basically taking the estimation from the base level models and then passing them as an input in meta model. So in this case, I am passing bag DT, boosted DT, and tuned RF as my base level model, and then the predictions that these estimators generate, 3 of them, I'm passing to my meta model, which is random forest, a simple random forest, and then training random forest using cross validation, right? So that's stacking. I'm not going to run it. It might take some time, but again, the concept is same. You don't need to hard code it. You can do it like this, right? And select is equal to 3. Anyways. Okay. There is a function called plot model, which has a lot of interesting plots that you would have to write a few lines of code if you were to do it yourself. So by default, it would give you an AUC plot, but you can change the plot parameter to get different plots. So in this case, confusion matrix, boundary. And obviously, with every passing day, we are increasing the plots because the way it's being structured under the hood is we can expand it horizontally, right? We have another interesting function called evaluate model, which is nothing but this one nice little UI. So if you are too lazy to run plot model individually, you can simply pass your model into evaluate. It would give you this UI, and obviously only on Jupyter Notebook or Google Colab or in any notebook environment, and you can just look at like this. It's the same thing. Instead of just passing individual plot, you can look at like this, right? Anyways, interpret model is another interesting function for model analysis. It implements Shapley value behind the scenes. So I can pass my tree-based model, which is XGBoost, GetBoost, LightGBM, decision tree, random forest, decision boosting class, or any tree-based method. I can pass it inside interpret model, and it would behind the scene it would implement the Shapley value, which is one interesting way to look at feature importance at a model level or at a prediction level. If you don't know about it, I do recommend read about that. It's a very interesting thing. It takes a little bit of time there is a little bit learning curve involved in order to read these plots. It's initially confusing, but once you get used to it, it's really good, and it's really powerful. So in this case, I'm passing get boost, plot is equal to reason, and observation is equal to 12. It means that whatever number 12 observation on my test set, this is basically the reasoning why model predicted whatever model predicted, right? So very important. Okay, and the last important function, AutoML. So what AutoML is doing is so whatever you have done so far in PyCaret in terms of model training and whatever you have done, we have a blueprint behind the scene, right? And what you can do, you don't actually, when you are doing your experiment, you don't need to remember these numbers, obviously, because if you train 50 plus model, it's not possible. You don't need to record them in Excel. You don't need to do anything, because if your selection is based on the metric and only metric, what you can do is run this function AutoML, and what it would do is it would basically go back, and all the models that we have trained today in this environment, in the active environment, it would basically bring out the best model out of it. It would finalize it. That means it would also, you remember we have a split it, train and test set, right? In the beginning, it would also not only bring out the best model, but that this time it would finalize it. That means it would fit it on the entire data set. So now you are ready for checkout, right? Now you can take this model and deploy it or do whatever. Predict model is a function, obviously, to predict on the new data set or on the test set if you don't pass any data set. So in this case, I am not passing anything, just predict model LR. So what it would do is it would basically predict on the test set. So this is my test set, and here's my prediction. So it would take the original data set and attach these two columns. Label is your prediction, 1 or 0. Score is your probability, just like predict proba in Scala. And these are the scores on your holdout set. But when you have new data set, you obviously don't have the label column to it. What you can do is just pass that new data set. Data is equal to new data. Obviously, you don't get this score grade because there is no label, but you would get the label and score column, which is basically the prediction and predict proba. Save model is how you save the model. So when I save model LR, model name batch model, let me show you when I load it back. This is not just one model. You can see this is the pipeline of sklearn. This is not one model, right? So anything that you have done in this setup function. So you have imputed missing values, you have done 10 other things, and then you have created a PCA with the 80% retention. It would basically give you all those things arranged in a sequence, so that tomorrow when you have new data set, instead of you manually managing it, you just apply or call predict on this object bash model, and it would take care of the rest. And if you want to see it graphically, these are your, so you basically, we started with this auto inference, which is data type handling. Then we have imputer. So whether there is missing value or not, we always create an imputer behind the scenes, so that when you have null values in production data set, we handle it. We don't throw an error instead. Okay, and if you were to choose PCA or any other things, you would obviously see the objects here. Okay. With this one function here, deploy model, what you can do is you can pass your model here, LR, under deploy model function, and just pass the authentication. And obviously by default platform is set to AWS. Not clear here. So this little function, this one line, what it would do is it would take your model and ship it to AWS. Let me just run it. Model successfully deployed on AWS S3. And if you have done a little bit ML ops before, you would realize it's not that easy. It's a lot of pain that PyCaret is covering behind the scene for you. Let me just exit out of full screen. If I show you my S3 account here now, there you see, this is the timestamp. This is the model that just gets uploaded to AWS S3, right? In next release, which is 2.1, which is due by next week, you can also deploy using the same pattern. You can also deploy it on GCP and Azure. So it's no different. Instead of AWS, you would write Azure. So very simple. Okay. Here are few utility functions. I'm not gonna. So they are in the notebook for you to check, but people ask me this question a lot. How do I see my transform train set? How do I see this? How do I see that? So there's a function called getConfig. See the documentation. You can almost customize anything in PyCaret. So there's nothing hidden. So do read the documentation. You can get or set anything in PyCaret. Just because it's not object oriented programming doesn't mean it cannot do what OOP can do. Okay. It generates because many people, and then obviously the intention is to have people build projects on top of PyCaret, use it like a tool where they would design their own customized Auto ML software. Logging system is obviously very important. So if you see get underscore system underscore logs, anything that you have done today, it has basically logged it in a very interesting way. And we use it for troubleshooting on GitHub, but obviously if you are building anything on top of it, this would be very useful for you. Okay, so the last thing I should talk about is, remember in setup function, you passed this log experiment is equal to true and experiment name is equal to juice1. What it is doing all this time behind the scene is logging every single hyperparameters, every single metadata behind the scene. So because I don't think so you as a data scientist needs to waste your time on logging these parameters in Excel or even try to remember them, right? So at the end of your notebook, if you simply run MLflow UI, and we are using obviously backend, we are using MLflow. In PyCaret 1.0, we were designing our own backend logging system. But then we realize it's a waste of efforts to duplicate work. If there is already a great work done by somebody, just using it. Okay, when you run this function here, MLflow UI, and if you are using command line, you don't need this this symbol. If you are using notebook, you need this exclamation mark. And then go to your Internet Explorer or browser and run localhost 5000. It would open up a Flask server on your computer, and you can see the experiment name juice1. Let me just click that. Here's your everything that you have done today. It's your scoreboard, just like a scoreboard in or leaderboard in any Auto ML, except that it's a very functional leaderboard. You can work with it. So all the metrics here. Let me switch to a different view. So all the metrics here, all the model parameters, tags, and few other important information, like for example size of the model, right? Because sometimes that's also very important. So you can see extra trees classifier is on such a small data set is even 4833 KB compared to if you see other models, they are like 20, 30, 40. Anyways, if you click on the model, you would see all the parameters at a model level. You would see the metrics, tags, and you have a trained model as well. So at this point, because this is using MLflow and you have experience with MLflow, you can also use PyCaret's deployment capabilities, but also if you are using Databricks, you can use model registries, you can use SageMaker deployment, you can use any kind of integration that already exists. So what we are trying to do is combining things. You also have a lot of deployment capabilities that you would get from PyCaret, but you would also be able to use the native deployment capabilities of MLflow. So that's really good, right? And if you want to, so let me just stop the server for a second. I'm restarting my notebook. Just want to show you one thing. and then we'll be open to questions. So instead of this, log experiment true, experiment name, if you also pass log plots is equal to true, right? If you do that, and now if I create any model, let's say, and if I go back to my server now, I can, if you would see now, you have trained model, which you have seen previously, but you also have these plots here, right? If you want, you can log them. Now, the benefit of this is obviously I'm using it on my computer, but this is not how you use it, right? If you're using in a team environment, what you would do is you would set the server of MLflow, the backend, to S3 for artifacts, and then some kind of tabular data set for your metrics and params, right? So either MySQL or PostgreSQL or something like that. Then it's really, really powerful, because then your entire team, doesn't matter where they are working from, they are working in this system where everybody is logging their artifacts and models and metrics and parameters. And this is not just this is not just experimentation, but you can also do entire ML ops with this, right? Because there is a model registry as well, where you could register your model and have A/B testing with a stage model and a production model and stuff like that, right? Okay. And also, just last point before we open up to question and answer is it's a PyCaret is not an abstraction layer, and I know many, I don't think so many people like abstraction layers, libraries that just hide all the details under the hood. That's not what PyCaret is. PyCaret is meant to replace your boilerplate code, right? And it is as flexible, as customizable as anything else in the world. So for example, if I want to create a light GBM model, and when I say create, I actually mean train light GBM model, right? So I can just do that. But if I want to have a specific learning rate, I can train light GBM with a very specific learning rate, in this case 0.1, right? And you can see learning rate. Where is learning rate? Here, 0.1. So it's not an abstraction layer. So anything, as long as it exists in light GBM, you can customize it. You can pass it in whatsoever you want, in whatsoever way you want. So in this case, I'm passing minimum child samples to 40, and if I see my light GBM now, it is 40, right? Or you could do something like this: import NumPy as NP, and then create a learning rate for I in np.a range 0.1 to 1 with a difference of 0.1. Create model light GBM learning rate is equal to I. Right, so now what you are doing is you are basically training 10 light GBM with a step of 0.1 in learning rate. And you could do it, so especially when you're working with regression and you're working with parameters like alpha and lambda, you could actually use this kind of functionality and then visualize the relationship of parameter with performance on the MLflow front end. And I'll show you in a second what I mean. So at the moment, I'm basically I've created a loop which is creating 10 different light GBM models with different learning rates. I don't need to be worried about metrics, parameters. I don't need to store it anywhere. I don't need to do anything, because everything is happening in the background automatically, right? It would be a waste of time for me to actually track these metrics manually. Okay, so I think the training is completed. Now, if I go on my front end, you would see all these light GBM, their metrics, so you can see here as well. But the better way would be to basically click on here and click on compare. Go here, put learning rate on x-axis and AUC. So you can see with the increasing learning rate on x-axis, AUC kept on declining. And obviously these are only 10 models, but when you would do a run on like 100 parameters, you would see a very, very meaningful visual, right? Okay, I think we have covered most of it. So one word, there is a lot of documentation tutorial on our website and our GitHub. Let me just show you. If you go to PyCaret GitHub, you would see tutorials. These are our official tutorials, a lot of notebook. You would see examples. There are over, so all these examples, and you would also see resources where you would see resources in English language. So they are like articles, right? So a lot of training material. Feel free to jump in. Our website is extremely user friendly, just like just like this website is very user friendly. Okay. I'll now open for questions. I can hear a lot of noise.
Okay, Moise. So thank you for the wonderful session and my comments. If I am reading the comments, people are loving the session, the library, and your efforts you have taken to build it up. So kudos to you. And okay, let me just take questions around.
Yep.
Okay, how the libraries like PyCaret are created? What programming languages are working at the backend, and how much time is consumed in creating such? Looks like a competitor is coming.
So it started in a school last year. So in all, it took almost 1 year in a team of 20 to 25 people. It took 1 year to bring the first version out for PyCaret. But we are also actively developing now. Obviously, we have a compared to 1 year ago, we now have a very big community, and many people around the world are developing it. So obviously, things are moving faster, and in but it took 1 year in the beginning to bring the first version out. Hello.
Sorry, there's some, I think, problem from my mic, so I'm not able to speak. By the way, Moise, can you go to the ask a question section? There are a lot of questions there, and maybe you can answer them.
Okay, so I think we are talking about the chat section, right?
No,
I
there's
think Moise.
ask a question section on the bottom of the
Oh,
screen.
okay. Okay.
Okay, you
Any
are.
specific reason?
Sorry, you were answering the second last question, how the libraries like PyCaret are created. So it got disrupted between. So can you please repeat the answer again?
Okay, so how libraries like PyCaret are created, what programming languages are working on the backend, how much time. So how it is created, I think it mostly stems from research. It could be research in school, it could be research anywhere else, but I think mostly it's coming from research. Programming language depend. In case of PyCaret, it's purely Python, but we are thinking about thin wrappers for other languages, especially R. But primarily it's Python. How much time it took? It took 1 year to bring the first version to production. So 1 year with a team of 20, 25 people, almost like a full-time job. So it took a lot of time. Any specific reason not to include deep learning models in PyCaret? So I think that wouldn't be fair to wrap deep learning models like we wrap machine learning models in PyCaret. And I think deep learning is its own separate area. And I think including that in PyCaret, we would kind of lose our vision. Our vision is to target canonical classical machine learning. Do I need to uninstall version 1 before installing version 2? No, not necessarily. But if you do that, there is no harm. But you don't need to actually do it. What you can do is pip install PyCaret is equal to 2.0 is equal to 2.0, or you could do pip install dash upgrade PyCaret. All of it would perform the same thing. How long before we receive our certifications? I'm not sure. I think that's not for me. Any version of PyCaret for image data? Well, it's the same algorithm, right? So if you can convert your images into you can transport it into NumPy arrays, you can use that. I mean, I've seen a lot of tutorials on Kaggle. People have done that, but we don't provide any transformers specifically. Moez, does PyCaret use sklearn behind the scene? Yeah, for the base library, I think sklearn is the most stable flavor. Had the most stable flavor of versions, but PyCaret is not designed to be algorithmic library. That means that if you have your own model which is following a dot predict and dot fit function, you can use that in PyCaret. So it's not specific to sklearn. The fact that our model library has many sklearn models is because it's the most stable option out there. But if you want, you can work with the Interpret ML Microsoft framework, any Linux libraries, CUDA libraries, anything that supports fit and predict, you can work with that. What was the motivation behind the development of PyCaret? So last year, when I was finishing up my graduate school, I kind of see the shift happening of people coming into data science. Primarily, like 5 years ago, you would see two kind of people coming into data science, and mostly was computer science. But that shift is happening, and over 50% of the people now getting into this field have no quantitative background whatsoever. That they are not from computer science, they're not from statistics, they're not from mathematics. They're actually coming from marketing, HR, finance. So I see there was a need for a very user-friendly product in Python specifically, right? So that was it. Any plan to release a guide for PyCaret, kind of a handbook? Do we have a working example? Sorry, this one first. Do we have a working example where we can generate intercept and coefficient? Yep, you would find it if you would see regression tutorials. You would find it, but obviously, if you are referring to like a statistical summary, vol test, and p-values and all that, obviously, just like sklearn, we also don't support it. But you can obviously find intercept and coefficient. You can find.
Okay, there's another question. It's actually on top. So it's saying that PyCaret is kind of a one-stop shop. However, how it reacts to big data? Can it be used for meeting deadlines in soft or hard real-time systems?
So in terms of, so my answer to that would be, if today you can use your computer hardware using any other library, you would be able to use PyCaret as well, right? Because it's the same algorithms. But PyCaret do support GPU training. So if you are dealing with like 50 million raws, I would suggest use algorithms that supports GPU. At this point, you can use XGBoost, LightGBM, CADBoost. These have native GPU supports, and they are really fast, right? Especially XGBoost and LightGBM, they're really fast. For next release, we are also enabling uh, other GPU algorithms. So, for example, random forest and logistic regression will also be a GPU enabled algorithms. But no library. I mean, if you are trying to run KNN model on 100 million raws, no software or no library would be able to do it in your local hardware, right? So you either need to have GPU enabled training or you need to have distributed processing. So I think there are ways you can work with big data, but obviously if you would run compare models on 150 million raws, I think your computer would burn.
All right, a lot of more questions going on. Maybe you can.
I think we
answer
can
them.
answer.
Yeah, he can answer them offline because this session will still be on even if we end the broadcast. Like people can come here and watch the replays.
Yeah, so depending of after the event, Moise can stay
Yes.
for 5 minutes and just answer the questions. Okay, so I would like to thank Moise for his valuable presence and making this very informative session. And moving up, I would like to conclude the event and first of all thank IBM, our prestige cloud and infrastructure partner, for extending the valuable support and this event and this platform, especially Kamar, Muhammad Ali, and the team behind who are supporting us. The next comes is AWS. That was our community partner. Pulse University. That was our community outreach partner. Being visible actually. I'm sorry.
No, nothing is visible. So
Okay.
there have been a lot of questions regarding people asking how they can start their data science journey, and I think that's like a wholly fully separate discussion. So we won't be going into that here. Maybe Misam, you can maybe do another session, another online meetup where you want to, if you want to discuss that.
Oh,
And people are
yes.
asking a lot about the certifications. There's a person, Sufyan Ali, he's talking about some data science course and badges, but it's not specified which he's talking about. So, Sufyan, if you can please elaborate on your question, that would be great. And yeah, I don't think any other questions or queries that are left unsolved.
Okay, so what I have done is posted a message that answers each and every questions of people, how to stay connected, how to involve into community. The best way is to involve into community. The best way is to involve into the community and learn from the community units that we have designed in Karachi.ai. I can show you up the screen for a while. Let me just share my screen. So whoever of the people are watching us, there are units section. So here is the units section. I have mentioned it into the comment section as well. Here you can see what is artificial intelligence. We have given the complete Coursera curriculum, how to apply it financial aids, what are the tracks you need to do, and how you can learn and excel into machine learning and AI and data science, right? So there's a complete detail out there. There are also the job boards as well and important YouTube channel links where you can learn from. So it's a complete package. You can join the Karachi AI group and look into it. Hopefully the question has been answered. Hello.
Yes, yes, perfect. Thank you,
So
Misam.
I would like to again repeat. I would like to again repeat my thanks to IBM as a cloud infrastructure partner and for the extended support for this whole event and the entire team, Kamar, Muhammad Ali, and all the people behind them supporting us to make this wonderful 5-hour landmark event in the history of, I think, nation as well. And moving forward, I would like to thanks AWS, Temples University. In the end, I would like to let everyone know we do quarterly meetups. So every quarter you get to engage with us. This was the first time we were going online due to COVID screening and different COVID distancing. And if you want to check out the meetup online, you can go and type Karachi AI on YouTube or anywhere on Facebook, anywhere LinkedIn. We are viral everywhere, and you can see us on the YouTube, LinkedIn, Facebook groups, and you can mail us as well, Karachi@city.ai. You can note down this link, https rebrand.ly, Karachi.ai underscore meetup underscore online to get all the details, all the files, all the presentation of today's meetup. I'll be staying in touch with the whole, all the people who have registered for this event and were part of this online section, and would be circulating them the details how they will be acquiring and issued the certificates. Hopefully, those who have filled their valid names and their details in the form, they would be issued certificate. I would like to thank everyone for joining. Stay humble and stay learning. Karachi.ai, enabling everyone to apply artificial intelligence. Thank you.
Thank you, Misam. Thank you, everyone. By the way, you can even after the live broadcast has ended, you can still come to the link and watch the recording, and you can still click on the schedule and resources, so you can get the links from here as well, even post event.
Perfect. I think hopefully everyone has learned that, and this event
Yep.
recording would be available on the channel of Karachi AI. If you write on YouTube, you will find that. Thank you, everyone.
Thanks, everyone. Have a nice day. Bye.